Sorry about the miscommunication. Okay, so you're now. Do you want to have the second one? The second one, if you need to. Yeah, I don't know. Okay, maybe you want to keep it up there and turn it on. Or play the speakers instead of having the EQ. We're good on EQ though. You're not here. Sure. Thanks, sir. All right. Live. Got it. Good news. What else? I thought you. Oh yeah. Hello, hello, test. Got some audio. Okay. Hey everyone. Hello. How's it going? Ready to learn about some smart contracts today? Programming and Solidity. Let's go. Thanks for coming out. I hope everyone is having a good time getting set up. Is anyone having any trouble getting to the internet, reading the setup instructions? Is everyone good to go there? All right. So I think we should be good. We'll be starting in just a couple of minutes. All right. So. Is that working? All right, I got you. We'll be starting in just a couple of minutes. I'm going to get everyone set up with the Wi-Fi, make sure everything's going good. There's a second mic.
Hey, one, two, three, four, five, six. Can you hear me in the stream again? Hey. Is it good? Check, one, two, three, four, five, six. Check, one, two, three, four, five, six, eight. Check, one, two, three, four, five, six, eight, one, two, three, four. Check. I one, two, three, four, five, six. Check, one, two, three, four, five, and six. Hey. Still choppy.
introduction and introduction stuff for you. Yeah. How long will you be? How long will you be? Yeah.
Check.
Hi, everybody. Hey,
Do we have Wi-Fi?
so I'm just gonna mute.
Wi-Fi. Let's start and chat a little. Someone's just going to start giving a little intro. As that gets together, we'll make sure we give you guys.
Can you guys hear me?
Yes, up.
Yeah.
Here we go.
Hello, everyone. Welcome for all the persons that are here with us and the persons that are online too. It's a big pleasure to be here. I'm so happy. And let's share my screen. Okay. I know that you are on my screen. Great. So, guys, I only need help because I didn't know here what I'm showing to them. How can I discover? Because I'm not using my own computer for this.
Yeah, you're looking to.
Okay, this is mine. Oh, perfect.
Okay. This is showing here. Yep.
Yes, this is mine. Perfect. So now I know where I am.
She has to click her.
Yeah, she'll have to click. And then when she clicks, we'll help that click as well.
So if she just changes her screen, it won't. So,
to let us
so,
know.
you have to, so yeah, so every time you change your slide, you have to click.
Okay, I need to do both.
Yes.
Okay. I try to remember this. So welcome again. I think now we can go live. And let's introduce yourself. But I don't like to introduce all of us. So Zach and Patrick come here. You can talk about yourselves. But my name is Solidity. The people we use call Sol. I am from Brazil, and I really love to teach, love to share my knowledge with you, and it's a big pleasure to be here. So,
Hey, how's it going, everybody? My name is Patrick Collins, Developer Advocates on the Chainlink protocol. Thank you, everybody, by the way, for your patience. Wi-Fi was working great, and then a whole bunch of people came in, and then it went, oh, wait, never mind. That's too many people, so thank you all for your patience. And yeah, we're looking forward to teaching everybody some Solidity, some smart contract fundamentals, and Sol exactly taking everything off. But if you have problems phones as you know they're talking or going along or as you're coding. Feel free to flag me and tell me to. I'm in the shop. All right. Feel free to flag me. So raise your hand. I can stand up here so that I can be seen. Feel free to flag me down or Zach down or any of the people who aren't talking, and we'll come around to help you. And then for those of you watching online, there are helpers online to help you out as well. So I'm really excited to get started here. And yeah, that's it.
Yeah, hey everyone, I'm Zach Irish. I'm a developer advocate as well for the Chainlink protocol. So I have a passion for teaching people, helping people learn and get into this Web3 space that's changing the game and changing how we do agreements.
Yes, I need to change here too.
1 second. These tech issues. All right, there we go. So how it's going to work today is we're going to go through part one. We're going to have an introduction. We're going to be talking about blockchain, smart contracts. What is a blockchain? What are smart contracts? How are they changing the game? And then we'll talk about a little bit of basic Solidity concepts. Just keywords, basic programming, getting a first smart contract out in the world. Part two, more local dev stuff, a little bit more using Hardhat and going through a typical developer workflow like you were in an actual project. All right, so essentially we'll go through a section, we'll lecture, we'll open the floor for a couple of quick questions. We're going to be strapped for time today because we're going to be covering a lot of material. So we won't be able to answer everyone's questions. We'll try to help as many people as possible, but this will be recorded. We'll put it up on YouTube. If at some later point in time you want to come back, you can always watch it. Reach out to one of the dev advocates here. We can give you our information and you can get some support. And for the online people who may be watching this, please go to the Discord. There will be a channel there, EthDenver Bootcamp. A couple of developer advocates, Harry, Richard, and Andre, will be supporting people there. So you can go ask technical questions, go to their Google Meets and get tech support. So yeah, please go there if you need support and you're watching this online. So for part one, the exercises we're going to, for the part one exercises, essentially all you're going to need is MetaMask, and you're going to need some Testnet, ETH, and Link. You're going to need Link and ETH for both the Kovan testnet and the Ringbeat testnet. If you follow the setup instructions, they should have kind of stepped you to getting those.
Zach, stand a little closer right here, please.
Sure.
This is picking up your audio. So you need both this and this.
Gotcha.
But the presentation mode, it's okay.
Yep, thanks for your patience again as we work through these technical issues. First time we're doing a live stream and in person, so tech issues are always gonna crop up. All right, so Solange is gonna take it away and walk you through the very basics of what a blockchain is, smart contracts, all the good things you see on the slideshow right now. And I'll come back in later after this and walk you through the basics of what Chainlink is and how that can take your smart contract game to the next level. So without further ado, Solange.
Thank you, Zach. I love your introduction. So let's start it. First, I will ask you to go to this link. I will go outside the presentation again. Wait a minute. This link is here. So EthDenver Bootcamp. And I'm asking you to add your name, where you based, and if you are here with me or if you are online. So I wait some minutes to you go to our collaborative pad. And to explain better this collaborative pad, all of us can interact, we can write, and you can delete everything, so be careful with this. But this is the best way for me to share the code with you, because I copy and paste some code here, and then you can do the same in your own computer. I know that I have one screen in front of others, so I need to go here. Hello, Alex, Arvine, Mike. Wow, nice to meet you. Perfect. We have a lot of persons over there. And you are just realizing that you can write in the same line. So go to a new line to do your presentation. Yes, this is amazing. It's really fun. And well, you are doing this, and at the same time, I will come back to the presentation. I'm pretty sure that this link is already in the pad, in the YouTube for you too. It's here. Wow. Guys, we have sound over there here in the projector. Like I'm here myself here. I will come back to the presentation. So let's talk about blockchain. I need to go to the slideshow again. I know that it's a bit slow to go, but we can do this. And let's start about blockchain. So what's blockchain? In some moment, I know that you have a screen over there. Yes. So I have the slides, but I will talk a bit more over the slides, not exactly what you are seeing in the slides, okay? I really like to say that blockchain, it's like its own name says, it's a chain of blocks. And what do you have in these blocks? We have the transactions. These transactions can be used to transfer values, but also to create, publish a smart contract, or to interact with some smart contract that is already published on the blockchain. So let's go. And when we are talking about blockchain, we are talking about a secure, reliable, and decentralized network that stores data, exchange values, and the record transactions, like I said before, in a shared ledger. And this is amazing because this is not controlled by anyone, by any central authority. And we have this in our computers around the world. Any of us can have a copy of this and can be part of the blockchain. So this is amazing. So what's blockchain? When we talk about blockchain, we can compare a centralized transaction with a decentralized transaction. And I'd like to go to the decentralized way. So we have a lot of nodes, and these nodes can communicate with each other, and the transaction is validated by the node. So we have a consensus of these nodes. So all of this is about decentralization. We are talking about some different architecture, or we are talking about political or logical. We are talking about what we have in a good way for the decentralization. So we have the fault tolerance, we have the resistance of the all kind of attacks, and also we have the resistance of the collusion. So this is the real network that we can believe. Yes, and I do not not to do the demonstration now. I will show with you later. And I will go directly to talk about the smart contracts. And then at the end, we can demonstrate more about this. I really would like to do smart contracts with you fast, as soon as possible. So let's talk about smart contracts. Before I go to the slides, I'd like to tell you that I'd like to do 2 questions with you. First, do you think that the smart contracts are contracts? Anybody? Is it a contract or no? Only a contract for now. Okay, you are good. Smart contracts are not contracts. It's excellent. And are the smart contracts smart? No. Wow, guys, you are excellent because the smart contract is not a contract and it's not smart. Okay, why it have this name? In fact, the guy who created the name, the concept of smart contract, it was Nick Szabo. Okay. The guy who created this is Nick Szabo, and he created this like 10 years before we have the first blockchain, we have the Bitcoin. And this is amazing because we are, this guy was in the future. And he gave this name, smart contract, because he's a cryptographer, he's a computer science, but he's also a lawyer. And then it's because of this that we have the smart contracts using this name. But we can say that some kind of contracts are smart contracts, and let's understand this better. So what's a contract and what is the reason to have a contract? We can say that a contract is an agreement between 2 or more persons or parties, any kind of parties. And the contract is a legal document that states and explains a formal agreement between these parties. What you need after this? We need to have this in a way that it's technologically enforced. And we don't need to rely only on papers. Think that any place can be fired, can disappear. So we need to have this in a digital way. And we can say that the digital agreements, when we have the internet, started in 18s, and the smart contracts is starting in 2009. And when we talk about the digital agreements, we are talking about to have the participants and to have a network that we don't have permission to be on that. So anybody can be part of this. But when we are talking about the centralized finance, the products that we have in centralized finance, this kind of product work very well when we have predictable conditions. But it's not in this way always. Guys, any of you can use this for me because I'm a bit lost to use both. I don't know if I am correct with this, okay? So talking about the centralized finance, we can have some problems with this. So let's go to the smart contracts because this is the best part. The smart contract, it's a self-executing contract, and it has the terms of the agreement, and this is writing directly in the computer code. So what's a smart contract? I can say that the smart contract, it's a kind of program computer, and this program, it's published on blockchain. And because of this, we can trust in this smart contract, and we know that the source code of the smart contract will not change during the time. We can change some data in a smart contract, but not the source code. And I already said this for you, so the smart contracts run it on blockchain. They are on the blockchain. I can tell for you that smart contracts are superior digital agreements. We talked about the digital agreements before, and because we have this on blockchain, they are better. Because we have the security, we have the execution guaranteed, we have the transparency of it, because it's in the blockchain, we can verify the source code. And we don't need to trust in third parties. We have all of this in the blockchain. And we can say that this is more efficient because everything it's in the blockchain, and we have the opportunity to migrate the existing manual process in a way that it's automated. And we can say that the smart contracts will solve the society's critical trust issues. We are talking in have some guarantees that it's cryptographic, based on math. Let's talk about Ethereum. Because I told before that the smart contracts was created before we have the blockchain. And the first blockchain that we have the smart contracts, it was the Ethereum. And to create the smart contracts on Ethereum, the language that it's most used, most popular, it's Solidity. Ethereum started in 2015. And in Ethereum, we have the main coin of Ethereum, it's the Ether, in the same way that the main coin of the Bitcoin blockchain is the Bitcoin. For Ethereum, the blockchain, the network is called Ethereum, but the coin is called Ether. And we are talking about a transaction state machine. So we have transactions, we have like photographs. Like I am here, okay? And to go here, to that side, I know that I am not here anymore, it's not a problem. What I need to do? I need to do a transaction. So in one transaction, I can change a state for one place, for another place. I can change a state for a balance, for example, to have more money, to give money, to transfer money to other place. I can change the state of a variable. Now the variable A, it means it has my name. So, but I can change with a transaction and save the name of Zach, for example. All of these are kind of transactions. And all the transactions, usually we count them like the functions of the smart contracts. And when we talk about Ethereum, we can talk about the nodes, the accounts, the transactions, I talk a bit more, and the pending transactions. Let's understand all of this better. First, what is the Ethereum virtual machine? This is a Turing-complete virtual machine, so we can run programs that we run in another computer. And this was built into the Ethereum protocol. Each node of Ethereum has the Ethereum machine inside. And it determines what is the outcome of all the logic of a smart contract. Like we can say that the smart contracts are executed in the EVM. And a lot of other blockchains today, they have a huge effort to be compatible with the EVM because of Solidity, because of this is the most popular language to create the smart contracts. About the Ether, I already said that this is the native cryptocurrency, and we need to have ethers to execute any transaction that is changing the state in the blockchain. So I need to pay for this. I need to pay something that we call it gas. Also, another like important and very useful point that we have in the blockchain are the tokens. The token, it's a kind of smart contract. It's a specific smart contract that we can use to transfer values. We can use to represent anything. We can represent like tables, chairs, money, whatever. I forgot to say that the Chainlink token, it's a token that's run on Ethereum. And let's talk more about Solidity. I'm really so happy in this part because I'd like to do smart contracts with you as soon as possible. So Solidity is the language that we are using to run the smart contracts, to create the smart contracts. And this language, we can understand this language, but it will be like translated to 0 and 1s that we cannot understand nothing, but the EVM can understand. I think it's this, because the other part I'd like to do live. I only talk about the gas payment before, because this is important. And probably you hear about, oh, the gas fees are so high, what I do now, what's happened. Let's understand this better. Like I said before, we need to pay to execute a transaction that's changing something in the blockchain, that's changing the state. And we are paying gas. Gas can be, we can have different parts of gas. We can talk about the gas price. It's how much is cost the liter of gasoline, for example. And we can talk about the amount of gas. So I'm here in Denver and I'd like to go to the Breckenridge retreat after this. How many liters of gasoline I need to go over there? And this is the amount of gas. Each operation in a smart contract has a different amount of gas. And to know how much a smart contract you cost, you need to multiply this amount of gas with the gas price that you would like to pay. So we choose how much we would like to pay to execute a smart contract. But if you would like to pay a very low cost, probably you cannot do this because any miner you validate your transaction. So your transaction are not going to the blockchain. I can say that we have a minimum of gas price for the miners to accept our transaction. And I have more explanation here. I know that we are sharing this with you later, and you can see more about this. One point that I can say for you is that this concept of gas limit, because when I send a transaction, I can say what's the limit that I'd like to spend in the gas. So if a smart contract is doing like a kind of loop, it will have a limit. You will not block all the blockchain because of this. So we have the gas limit on a transaction, and we also have the gas limit in a block. We can have some amount of transactions in a block. And this was increasing in past years. So with this, I think we can go directly to create our smart contracts. Yes, perfect. Let's go outside this presentation. And I come back here to our, okay, let's, wow, we have a lot of persons. I'm so happy with you guys. Oh. Okay, let's go now to Remix. I put two options for you. the secure and not secure remix. Wait a minute. This is the non-secure. And also you can go to the secure version. What's better for you to what's running now? Okay. You put this here and hope to be fine. Okay. And this is remix. Perfect. Let's create our first smart contract. How can I do this? I'm going to the second icon over there. Thank you. Okay, thank you. Patrick, would you like to pick up a chair for you because you are suffering here? Oh, this will be great.
Just the mic stand.
You are amazing. When you just arrive in a remix, I hope you open. Sometimes remix can take a lot of time to open, okay? So be patient with your remix, but this is the best tool for us to start it. And then now we are going to the second icon in the left. This is the File Explorers. And we are going to create a new file. And I have a big challenge here because probably I will change my screens because I need to see that screen. And I know that the people are seeing me here.
You can see this one.
Yes? Okay, perfect. But I can't see. This is the problem.
Better?
Okay. No, I think you can be here.
Okay.
Okay, thank you. So in Remix, our first smart contract you call the register. Come back here and create. This is create register.sol. With this smart contract, we are doing a lot of things, okay? I have like a copy of what I need to do here. Wait a minute. I know that disappeared, and I will come back only what you need to have here. For now is this. End of the remix, go to this. Perfect. So our first smart contract, I will copy for the pad and you can paste in your own place, is this. From begin to end. And what I have in this smart contract, first, let's put this in remix because I have the order here. Perfect. What I have in this smart contract, first I have a comment that it's specifying the license that I'm using. Then the pragma, it's a word used to define the version of our smart contract. So we are using the language Solidity in the version 0.8.7. The word contract, it's defining our smart contract. So this is the register 01. And everything that it's inside the smart contract, like here, I close it now. Everything that's inside this, it's our smart contract. And what I have inside? First, I have a variable, it's a string, and I'm telling that this is private, but this means that this variable can only be accessed inside this smart contract or when I try to save information over there because I'm sending a transaction and anyone can see my transaction. After, I have two functions. One called getInfo, and this is a public view. The view, to be a view, it means that it's not changing nothing in your smart contract, and it's returning the string that I save here in the variable info. I have another function called setInfo, and this function is used to put some information in our smart contract, to save information inside this variable. This is so easy. Probably, I don't think you have debits with this, but our goal is to publish this on blockchain. How we can do this just now? Probably you saw before all the requirements, so I hope you have MetaMask installed. I'm going to my MetaMask just now. And Remix is trying to connect to my other account. I will switch to account that I know that I have some ethers on Rinkeby. Can you imagine it if this is real? Wow. But it's Rinkeby, it's only Rinkeby, okay? So this is my account, and I know that I am connected on Remix, but let's check some parts. Now I will ask you to go to the third icon on the left. This is the Solidity compiler, and it's useful for you if you enable the auto-compile. So you don't need to think more about this or to compile your smart contract again. Then, if this is done, you can, if you done this before, you can click compile register.sol, and you can see on the left side that you have a green sign over there. It means that my smart contract is compiled and it's okay. Now, let's go to the fourth icon over there is the third button. And this is the deploy and run transactions. And what I need to do here, I need to change the environment. You can see now that this first environment, the JavaScript VM, it's a kind of blockchain simulator that's running only in the memory of the browser. But we'd like to publish this in a real network. So let's change the environment to injected Web3. The first time that you do this, Remix MetaMask, you ask you some permission. It doesn't ask me, but it did nothing yet. Yes, you can see that I'm trying to do it, but it's not working. I will refresh my Remix. This is not a problem. And meanwhile, I'd like to say to you, be careful to copy and paste the smart contract, not cut, because we have a lot of persons that need our smart contract, okay? And here I come back, I am in Remix again. So I'm going to discover if my register is okay. Wow, my register disappeared. This is great, I can paste it again. Then I'm going here to understand why it's wrong. Okay, this is new for me.
Just refresh it.
Yes. So I will refresh again. Wait a minute. Thank you, Jenny. Oh, now it's better because my smart contract is here. And then we can see in the third icon that is green, it's already compiled because I enabled the auto-compile. Let's go to the fourth icon and go to injected Web3. Okay. Okay, I got it. It's here. Do you know it? Okay, light.
Better? Better? Is this better or is dark better? This is better? Okay, cool.
Okay. Okay. It's better now? Okay. So let's do it. We are going to the fourth button, fourth icon. And now it's okay. I am here in Injected Web3. We can go here and you can see that it's connected on Rinkeby. I select this on my MetaMask wallet, okay? You need to select the Rinkeby network in your MetaMask wallet, and you can see the same here. I know that the guys are not seeing me anymore. I will turn off my video. You can use the other. Okay. Perfect. Now I will go down to the contract. I have only one contract here, so it's the register 01. I can deploy this contract just now. MetaMask, you open a new window for me because I need to approve this transaction in my wallet. It means that it will spend some ethers in my wallet and I need to approve this in order to publish my smart contract. I'm confirming. And let's go here in the path. Oh, thank you. Let's put your name and your address. Let's find mine. When we are talking, it's here, it's confirmed now. I can see my MetaMask wallet. I don't know what's happening. But I can see down in the left side of the deploy and run transaction, scroll down and go to deployed contracts. You can see the register 01 over there. And you can copy the address of your smart contract and paste it here in our path. You can do the same with yours. I'd like to have your smart contract to interact with this in the future. And let's expand this register 01. And you can see that I have a get info function and I don't have nothing stored. And I have the set info. I can add any information here. So let's put EthDenver. Now I'm sending a transaction to the blockchain. So I'm clicking on set info. It will open my MetaMask wallet. I need to, again, authorize this transaction. I don't know how it's so long now. It's not supposed to be here. Okay, confirm. And wait some seconds to have this transaction confirmed. And after this, we will check the get info again. Probably it's confirmed. Let's go to get info. Yes, and now that I have the information EthDenver over there. So to do it again, only for you, add an information, whatever you would like to do in set info, click on set info, approve the transaction on MetaMask, and after your transaction be confirmed, we can go to get info and see your information over there. I'd like to check from other person. Josh, I don't know where are you, if you are here or online. I check your smart contract just now. How can I do this? Because I'm using the same source code, I can interact with any smart contract that is already published on the network and have the same code that mine. Usually to interact with a smart contract that it's already published, you need two information. One, the address of that smart contract. Second, the ABI. The ABI is telling us what kind of functions we have in that smart contract. Or if you are using the same source code, we already had the ABI. To check the Josh smart contract, I will add the address here in the @address, and then I will click on @address. Is Josh here or online? Hey, Josh. You can see now that I have two instances of register 01. And if I scroll down, I will see what's Josh saved in his smart contract. EthDenver too? Wow. Yes, great. Let's do it. And we can see, I can see all of this smart contract. I know that we have a lot, so I will pass this, I will go to the next. And Zach, how many time I have to do this part of the smart contracts? Until what time I can do this? Yes? Like I have 5 smart contracts to do. I will do the next, and you tell me when I need to stop, okay? One more? Okay. So this is the basic smart contract, very, very basic. We only are storing information and retrieve this information. Because I know that I have only one more to do, let's go to something very complicated. I go to the last. Let's create another smart contract. You are creating now the register 05.sol. And I will add the smart contract here for you. This is a huge smart contract. I will do the process just now. If you need to create with me, the first point, the first action, it's go to the second icon in the file explorers. Below the default workspace, you can see an icon to create a new file. And this is the register 05.sol. And then you can paste the smart contract over there. And I will explain what I'm doing here because this is I have the others in the middle and I am in the last one. What we have different here? Remember that we have one information to store. Now I have an array of information. So I can have a lot of information. Also, I have another kind of variable, called it's the type of address, and it can store an address of Ethereum, an account address, or address of a smart contract, or address from an external account like our account, okay? And also I have a mapping. What's a mapping? A mapping is like a index value kind of variable. So for an address, I can tell if this address is true or false, and I'm calling this a whitelist. It's because I'd like to only our the people or the address that I am adding in this whitelist can add information, can change the information in our smart contract. Now we have new information over there, the constructor. What is the constructor? The constructor, it's a function that's called only when the smart contract is being published. And in this constructor, I'm doing 2 points, 2 things. First, I'm defining that the owner of this smart contract is that account that's publishing it. So this is the message.sender. In the same way, because we have a whitelist just now, I'm saying that this person, it means us, we are whitelisted to change the information in our smart contract. Is this? After this, I am introducing for you a new concept, the event. The event is something that a smart contract can like send the information outside. It's a kind of log that it has in a transaction in the blocks, and like other programs can monitoring this kind of information. After this, we have the modifier. We use the modifiers to help the transactions, to help to help it to have different usability or different access in the functions of our smart contract. I have 2 here. The first modifier, it's checking that only the owner, the message point sender, is the owner that I saved before. Other person cannot publish this smart contract, cannot interact if some function has the only owner modifier. If you can stay, if it's better here for you, I think it's not for me. It's good. Okay?
It's better for me here.
Okay. Okay. The other modifier is the only whitelist. So only the address that we are adding in the whitelist can do something. I don't know what yet, but can do what I defined. So the getting function, it's exactly the same. I think now it's better for you. It's exactly the same. I didn't change nothing. But now the set info has the modifier only whitelist. It means that only that account that it is in the whitelist can save information in this smart contract. Also, when I am here, I am emitting that event that I explained before for you, the event info change. And here I have another point that you can see that I'm defining an index. Because I have an array, I can say like, add this information in the position 0, or in the position 1, or in the position 2. So this is the index of our array. In the same time, the set info now only makes sense if I'm trying to change some information that is already in the array. To add a new information, I'm using the add info function. And here I don't need to take care about the index. I'm only send information, and this information will be added at the end of the array. The push is adding the information at the end of the array, okay? And I'd like to return in what position it is. Then I have a function to list all the information that I have in my smart content. If you have a huge smart content with a lot of index, this is a problem, okay? You cannot return everything. But for now, we can do this. And we are almost finishing the explanation of this. I have two functions to control the whitelist. One to add other address and another to remove address. In fact, I'm not adding or removing. I'm only saying that mapping, remember that the mapping is something like a value, a index and a value. So the index is address and the value can be true or false. It's only this. Let's publish this smart content. Do you have any doubt about it? Is it okay? Okay, let's do it. So let's go now to the fourth icon again. Probably you have this already compiled and it's green. You can see now that I have the register 05 over there. And I will deploy it. Thank you. I really enjoy to have all these guys helping me. Thank you, guys. And I clicked on deploy button, and now I need to confirm this transaction again. Confirm. And you can see that in the left side, I go down a bit because I'm waiting my transaction be confirmed to appear here in deployed contracts. It's here just now, register 05 is this. And we can see that we have a lot of functions over there now. And what's the difference between the orange functions and the blue functions? Anybody know? Okay, I will tell you. The blue functions are not changing the state of the blockchain. So we are not paying gas to use this kind of functions. And in the same time, it's like we are doing a query. We are only consulting and not change nothing. In the other side, all the orange functions are changing the state on the blockchain. So we are changing something, our smart content. Let's do it. First, I will add a new information here. I'd like to add my name. So, add info. Let's confirm it on MetaMask. Confirm. Almost. Confirm. Go. Now it's good. And I'm waiting the transaction be confirmed. I can see the transaction here in some point. Here. Go. Okay. Here we have in the right part down, we have the transactions too. You can see over there. Let's go to the list info. And I have only one information in my string. I will try to get this information using the index. It is in the index 0. It's okay. But if I try the index 1, you will get an error because we don't have nothing in the index 1 yet. Okay? Let's add another information. Now I will add the Zach. All of our developers are like, no, I'm not calling you. I only use your name in this smart content, Zach. So let's do it. Add the info. Confirm the transaction on MetaMask again. Okay, it's confirmed. Go. Yes. I'm looking down here in the right part to discover when it's done. It's confirmed. Let's go now to the get info in the index 1. Now I have information over there. Zach is over there. And in the list info, I have 2 developers advocate here now. Let's add Patrick too. Add info. Confirm. It's interesting, MetaMask is taking more time than usual because it's like, I understand that it's calculating, it's taking more time to calculate the fee now. It's confirmed. Let's go to the list info. Now we have the 3 developers advocate over there. But I'd like to change one of us. I know that Harry is online and he's helping us. So I will change my name. I will put the Harry name in my place. To do this, I know that I am in the index 0. I will explain this to be better. Index 0, Harry. And I will transact now. You can see here that the fee are changing. This is take more than usual, more time than usual. Wait, this is very fast. And now I will not be in my smart contract anymore. Let's go again to the list info. And now I know that this is small, but we have Harry, Zach, and Patrick in this smart contract. Okay. Let's check the index 0. Yes, it's done. Let's check the owner. Let's do it. The owner, it's me, because this is my smart contract. And in the whitelist, I can check, for example, that I am listed in my smart contract. If you go over there, I can see that it's true. I will change my account now. I create another account here. Yes. Now I am using another account. And if I came here in the whitelist, it will be false because this second account is not in my whitelist. Can I add this account in my whitelist? Let's try it. But probably not now. Why? Because I'm not, to do this, I need to be the owner, and I connected in the second account. So the second account can't add a new person in this smart contract. Okay, I cannot do this. Let's come back to the first account. I know that I am connected now, and if I try to add member, now I know that I can do it. You can see that we don't have an error anymore, and I'm confirming. Wait a minute, let's check the whitelist again. Now it's true in the whitelist. Perfect. So if I come back to the second account, I almost finishing here, okay? Now I am in the second account. So this second account can add me again. I'd like to come back to my smart contract. Add info. Confirm. And in a few minutes, I can see that we have now 4 developers advocate here. It's pending, it's done, list info. And now I am in the index 3, not in the index 0 anymore. So here I can implement other kind of functions like to remove information. I show you how to change information in some index. And I try to create a kind of database here to you understand better one of the points that we can do. We can create tokens, we can create different applications. And this is very basic, but it's good to you to understand better this. In a few minutes, we will start to show you about the Chainlink products, okay? And Zach, would you like to come here now? What's the next now? Yes. Huh? Yes. What do you
Appreciate
need to do in here? I can help you a bit.
I'm just going to go back to the presentation.
Okay.
I can hold it for now. I'll let you know. Appreciate it. Thanks for being patient with the technical difficulties we're having today. For the Wi-Fi, we're still trying to get it back up and running. So we're going to have lunch at around 11:30. We're going to try doing some stuff with the router and getting it up and running again. So if you're having Wi-Fi troubles, try to keep it in there. Stay in here until then if you can. If not, we are streaming this, so you can go to one of the other venues, watch the stream. We have people online for support. We'll try to support you from there. And of course, if you can disconnect from your phone and only connect to the Wi-Fi from your laptop, that'd be very helpful. I think it's just too many connections to the router here, so that might help. So, and thanks for that awesome presentation, Sol.
Thank you.
Sol is a guru at Solidity, so she's been doing these activities for a while. So,
It's over there, and you need to click here.
does it? Okay.
Yes.
So you already went through
Yes.
those, right? Okay. So that was just kind of basic Solidity and blockchain stuff. This event is hosted by Chainlink Labs, of course. We're going to talk about the Chainlink protocol a bit, what it is, the problems it solves, and how Chainlink takes smart contracts to the next level. So when Sol was talking, she mentioned, smart contracts aren't really contracts and they're not really that smart, right? Why are they not that smart on their own? Well, they have a lot of cool properties, but smart contracts can't actually natively talk to the outside world. They can't connect to off-chain data and resources. So no APIs. If you're a programmer, a lot of programmers connect to APIs and get data into their apps that way. Blockchains can't do that. Why can't blockchains connect to outside data sources? Well, the main reason is because blockchains are deterministic, right? So you have all of these nodes all over the world communicating with each other and trying to agree on what the blockchain is, what data is that blockchain storing. And because of that, blockchain code needs to be deterministic. If it wasn't deterministic, the nodes wouldn't be able to come into agreement. And so in this diagram here, you can see on the left, the deterministic side would be your right. Nodes come into consensus on 1 + 1, right? Deterministic, math, 1 + 1 = 2. They're doing a great job. On the right, they're connecting to some outside data source. Let's say they're connecting to get the price of a stock or something, like Tesla USD, right? And stocks can be pretty volatile, especially the Tesla stock, second to second, right? So the node on the bottom left calls Tesla, and it gets $400. I don't know what the price is right now, but it gets $400. And the node on the right gets $400.01, right? Because it maybe pinged it 1 second later. Maybe the price changed that much. Maybe it went up by a whole dollar. Either way, now the nodes are recording different prices, and they can't come to consensus on what that price is. This is why we can't bake any kind of outside data sources into a blockchain. So we call this the smart contract connectivity problem. Smart contracts are great, they're immutable, they're decentralized, they have all these powerful properties, but they can't connect. And so we're stuck just transferring ownership and representing ownership on a blockchain. That's it. Of course not. So there is a blockchain oracle that serves as middleware that can connect blockchains and smart contracts on those blockchains to outside data sources. So you may think a naive way to create a blockchain oracle is just trust someone, trust a data middleman that will take data and put it onto the blockchain. But this is a very insecure design, right? We have this decentralized blockchain infrastructure. It gives us all those strong properties. And then we trust a single node to get us essential data that will cause that smart contract to execute, right? That node may be corrupted, it may be hacked, the person running it could be bribed, they could go down due to some crazy weather event, who knows? And then all of a sudden, you have this smart contract with millions of dollars in it, and the core data is down. So this is a design we do not want to go with, right? Just a single centralized oracle. What we need is a decentralized oracle network, something that matches the properties of the blockchains that these smart contracts are deployed to. Ideally, a bunch of different nodes connected to different data sources, aggregating data in those nodes, communicating with each other, and submitting data down to the blockchain. And that is precisely what Chainlink is. Chainlink wants to make sure that blockchains stay decentralized and smart contracts stay decentralized and reliable end-to-end at every point of contact to that blockchain, right? If we have a single point of failure anywhere in that blockchain, that's going to be attacked, right? So if we really want to get the original promise of smart contracts, executable code that doesn't rely on a middleman, you're going to need a decentralized oracle network somewhere there. So here's an example of some Chainlink nodes, communicating each other in a decentralized oracle network. We call those DONs to get price data, right? So you can see in the diagram, they're all talking to each other. They get different prices because they talk to their different data providers. They're aggregating it, and then they submit all of that data onto the chain in a smart contract, each individual observation, and all those observations themselves get aggregated into a final source of truth. And this allows you to take smart contracts to the next level. Not just regular smart contracts, we now have hybrid smart contracts. So we're moving even farther beyond smart contracts. We had digital agreements, centralized digital agreements in our services. We had smart contracts that decentralize everything. Now we have hybrid smart contracts that are connected to outside data and computation. And this really opens the door to of the limits on what we can build with smart contracts. Now you can really build anything you can imagine with a smart contract. And the beauty of it is, because this is kind of a middle layer in between the real world and blockchains, Chainlink networks are blockchain agnostic, which means as long as the blockchain can run smart contracts, Chainlink can be there. All right, so one of the most popular Chainlink services is the Chainlink data feeds. These are one of the most adopted services and is powering most of DeFi. So if you've been in the blockchain space at all in the past couple of years, I'm sure you've heard the term DeFi, decentralized finance. DeFi is essentially traditional financial agreements that we would, run it behind in a bank server or, a trading fund server and put on the blockchain. So it can be decentralized and not owned by anyone. If we want to make these DeFi smart contracts actually work on a blockchain, though, they need price data. If you're trading two currencies, you need to know what the price of those currencies are versus each other for that to work. So Chainlink data feeds power price data into DeFi smart contracts, enabling them to do what they need to do. And you can see this live if you go to data.chain.link. I'll see if I can get this up and running on here. One second. I'm going to try to do this so we can see these data feeds in action live. Cool. If you can just pull that in there.
Yes. But we need to left here.
So what this site is basically just a convenient GUI for you to be able to see these data feeds in real time, delivering data to the blockchain and what data they're getting and who's delivering that data and the history of that data. It's a fantastic resource. So you can see right now the data feeds are securing 60 billion, almost $61 billion on blockchains. So what this means is that the amount of money flowing through the smart contracts that Chainlink is currently securing is around 60 billion, right? This is why we can't use a centralized oracle. If an oracle was attacked, 60 billions of dollars could be stolen. So security and reliability is of utmost importance. So let's take a look into the ETHUSD data feed. Coming up. Okay, so it looks like we're having some GUI issues here, of course. But we can also view this data feed on Etherscan, right? So you want to go to a decentralized solution and see where these data feeds are posting. You can go to Etherscan, click on the address of the feed. So these feeds post to a single contract on chain, and you can look at that contract and all the historical data on chain on Etherscan. So if we go here, you can see contract. You can look at the source code that's going on behind these data feeds where these nodes are posting to. And you can click read contract. We can go down here to, we're going to need a latest answer. And this is giving the latest price of ETH USD as reported to this contract by that Don. Okay, let's get the presentation back up.
Yes, it's here and this slideshow. Yes, only click on the slideshow.
All right, so that's kind of the essence of Chainlink data feeds. There have been attacks to centralized oracles in DeFi, and lots of money has been lost to this. So again, I can't stress it enough how important having a decentralized, reliable oracle network is when you're developing your smart contracts. So now I'm going to teach you how to use these data feeds in your smart contracts. If you're developing, what do you need to do to get this data into your smart contracts and build some awesome, badass DeFi applications? So again, we're going to be doing this in Remix. And for this demo, I'm going to follow along with the docs. The Chainlink docs, I think, are very good. They're very clear. I use them all the time if I forget a workflow. And then after this, I'll have an activity where I'll let all of you go on your own and try to use data feeds in your smart contracts. And me, Sol, and Patrick will come around and kind of help you code and go through any technical issues you may be running into.
Would you like to operate and you explain?
Sure. Yeah.
Okay, it's good for you.
Yeah. Can you go to the docs?
Yes.
All right. So Sol is going to run the machine while I explain what's going on. So we're going to go to data feeds. So if you go to docs.chain.link, you'll see all of the chains and all the services, chain services that we offer. We'll be going through all of those throughout this bootcamp, right? But we're starting out with data feeds on the left. So if you go to the left and click using data feeds, right? This is going to be where we explain how to use data feeds in your smart contract. And so I'll scroll down and you see we have this awesome example code. Now this is ready to be deployed and sent to Remix. So if you scroll down and click open in Remix, this will automatically open Remix for you and put that contract there so you can mess around with it. Of course, there's also stuff you should read up there. It'll explain how the contract works, but I'll go through and kind of explain what's going on in this contract, right? So of course, we have our import at the beginning, pragma Solidity, that's telling the compiler, hey, what version of Solidity am I using? And we're importing the aggregator v3 interface. This is the import that allows your contract to talk to data feeds. And so in this contract, we've called it price consumer v3. And in the constructor, we are connecting here, we're saying this variable called price feed of type aggregator v3 interface, which is from our import. We're giving it this address, which is the price of ETHUSD on the Covan network. This is the contract that the ETHUSD DOM on the Covan network is talking to and submitting data to. So there's a whole list of different feeds in the docs that you can connect to. Different networks, different price currency pairs, even I think there's proof of reserves on there, all kinds of different things you can get. And proof of reserves is a product that, for these collateralized loan services, shows how much reserve they actually have and makes an audit trail on the blockchain as a data feed, right? So we have our constructor. So when we deploy this contract, this will say, hey, point our smart contract to the ETHUSD feed on Covan. And then we have a single function, get latest price. And can you guess what that function does? It gets the latest price, right? So that's the contract. That's how easy it is to use price feeds. So to understand this function in a little bit more detail, if you look at it, it's essentially calling from our imports, it's calling that price feed that we initiated and just saying, hey, get latest round data, and it's going to return all this other stuff, answered in round, timestamp, started out, price, round ID. Most of that's metadata of the actual price point that's been put on the chain, but the main thing we need is the price. So we're returning price as an integer. So let's go ahead and make sure that this contract is compiled. So if you go on the left tab, I think I got it right now.
Yeah. Okay.
So if you go on the left tab, and you'll see that, scroll up real quick. It's pointing to the right compiler version. That's the same compiler version we have in the pragma, so that's good. And click on the compile button on the bottom. Or you can turn on auto compile, and that will change it as you code, right? So if you hit that checkbox on auto compile, every time you type, it'll start recompiling that contract for you, right? So we've compiled it, and what this is a contract, and converted it to bytecode. This is converts it to the language that the blockchain can actually understand and save, right? So now we're going to take that compiled bytecode and we're going to deploy it onto the blockchain. Awesome. So this is important. Remix always defaults to JavaScript VM. That's a local environment. And if we're connecting to feeds, we're trying to connect to some test network where the feeds are actively posting data. If you post to the JavaScript VM, it'll just be on your computer. Your computer doesn't have a native connection to the Chainlink data feeds, so it won't know where to go. So what's important is to switch it to injected Web3, right? And because the MetaMask wallet we have installed is set to Rinkeby, you can see that it sensed that, and it knows that we're about to deploy to the Rinkeby test network.
But you need to go to Coven that others.
Yes.
Okay.
So this is actually, you saw that the ETHUSD feed we have in this example is on Kovan, right? So we're going to need to switch our account to Kovan. Another thing you could do is go to the docs and find the ETHUSD feed on Rinkeby and just replace that address. But to keep it simple, we'll do it like this for now. When you get to your exercise, we'll walk around and you'll be able to just pick any address you want, pick Rinkeby or Kovan, wherever you want, deploy there, and we'll help you out. So, yep, we're connected to Kovan, we're good. We have ETH in our wallet, so we're good to deploy. We can keep the gas limit on the left and all that on default.
Yeah.
And another important thing is making sure that the contract right there, that contract field is pointed to the right contract. So we're importing a contract in that aggregator v3 interface, and Remix defaults to pointing to that imported contract. And this gets me all the time. I'm deploying, I send my code in, and I look at it, and there's no functions, there's nothing. And I'm like, what just happened? And it's because I deployed the imported contract, right? So we're gonna wanna make sure we're pointed to the right contract, Price Consumer v3. That was the name of the one where we actually implemented everything. And we're gonna click deploy. MetaMask is gonna do its thing, come up. We're gonna go with the defaults. You know, it is important if you're ever on mainnet to read what those gas fees are and make sure you're not about to spend a lot of money. But of course, we are on testnet, so everything's dirt cheap and the money is free. So feel free to just hit confirm on that. And you have to wait a little bit. In this case, it's already deployed, but you know, we're sending a transaction to the blockchain. The blockchain has to read that. All the nodes have to come to consensus and send a message back to us saying, hey, contract is deployed. And so we have that, and we have our button for get latest price. That's our function, and boom. It calls that same data that we saw on Etherscan, right? That's it. That's how easy it is. You just have to make an import, point it to the right price feed, and boom. You've got a smart contract, connect it to the outside world, connect it to the most secure Oracle network you can connect to, and you're good to go. So where we're going to go from here is I'm going to let y'all mess around with that price feed. Back at the beginning, I left QR codes for the part 1 activities. You can go to that QR code, and Sol is posting some information in the Rise Up, and you can go through and do this yourself. We'll come around, we'll help you code. If you're running into any errors, have any questions, we can go through it. Real quick, is there any couple of just understanding questions? You know? Like any questions about the Chainlink network, data feeds, how they work, anything like that? Yeah, so the question was, what is the source for the data feeds? Like who's providing data to the oracles, right? Great question. So the oracles themselves, right, they source this data from a variety of sources themselves, right? They don't want to rely on a single data source, right? So they'll connect to any kind of data provider, high quality data providers, right? And then they're going to aggregate that data themselves. So this could be any data provider. They could be the data provider if they want to be, if they're a data provider themselves, you know. So exchanges, just price data providers if it's price data, whatever it may be. Then they're going to aggregate all that data in the Oracle itself. And then each Oracle is aggregating all these data sources. They're communicating, and again, then you get that one single answer that's aggregated between all of the oracles. So you have these two layers of aggregation where the oracles are talking to a variety of data sources and the oracles themselves are being aggregated between each other. Go for it. It depends on the oracle networks and the needs of the oracle networks, right? So for price data, a lot of oracles will end up using medians, right? Because medians are, they're not as, they won't get messed up by outliers, right? Like if you have one giant outlier from a data source and you medianize it, you won't get that. So a lot of the oracles medianize themselves, and then if you look at a lot of the contracts, they get medianized, between the oracle answers. But the flexibility of the Chainlink network allows any kind of data aggregation to occur.
You decide aggregation, or I could basically program my own node.
You can make your own node. A bunch of Oracle network node operators can come together, and depending on the needs of the smart contracts, they can change the aggregation method. All right, one more. Yeah, great question. So basically he was saying, all right, now I looked at the price feed on the Rink B price feed that we're using, the heartbeats every 30 minutes, and maybe he needs data every millisecond. What can he do for smart contracts if he needs data that fast, right? So if you go to the mainnet feeds, they do tend to have a faster heartbeat, and they also have a what's called a threshold that needs to be reached, a price deviation threshold. And if those are surpassed, so if the price moves a little too much, it'll automatically trigger an update, even if the heartbeat hasn't been reached, right? So even if 30 minutes hasn't elapsed, right? And at the end of the day, if you really need a even faster order, like you need it down to the millisecond, right? A price feed can be built for that, right? So each of these DONs is their own network, right? So a DON can be built up to fit your needs for your smart contract. Sorry, what was that? Yeah, it depends on the DON, right? So the DONs, like the price feeds that you see on data.chain.link, they are funded by the users of those protocols, and they kind of support that. So, and it depends DON by DON, right? Yeah, I would expect that if you want like every millisecond some data, that might be a little bit more expensive, but it really depends.
Somebody asked a question, and it's like, just repeat the question so that everybody can hear. Yeah, people can hear.
Did I skip one?
Just for that one.
Cool. Yeah, so I think due to time, we'll go ahead and move. If you have any other questions and you catch one of the TAs around, we'll help you out. We'll answer any kind of how this works questions. We'll help you out through the exercise and deploying price feeds. So yeah, I look forward to helping you code. Let's get to it.
Hey everybody, it's Andy Boyana from Chainlink Labs. We're getting into the exercises. Thank you so much for your patience. I'm on my phone here. I'm at the event. Here's what it looks like. As everyone is kind of get ready to do these events, really appreciate your patience earlier on as we kind of sorted out how do we do online and in person together. These are some of the challenges we face. We're here in Denver. It's EthDenver. You can see it's nice. Snowy out. We've got a great turnout, and we really appreciate the turnout that is online as well. We see your questions, we see your comments. We love the Chainlink community. Shout out to Johnny Mustang for those great supports. Please reach out to us. We'll do what we can to send you a t-shirt or something like that.
Yeah, that's
so as Zach said, we were jumping into exercise 2. please continue chatting in here. Stick around for the future.
Would you like to
The stream might go a little
If we can
out and in as we adjust some of our settings, try and
Put it
make
on
it a
the
better
screen here.
experience overall for you and
Where
for
is
the
the
people
QR
here
code?
as well. Again, I'm Andy, Chainlink Labs. We're at EthDenver. The Smart Contract Developers Bootcamp. This is exciting. This is fun.
So it's on,
We love you guys, and we will be
beginning.
back here in a little bit with more of this boot camp. Stay tuned. Keep coding. Rock on.
And yeah, put it in the bed. Cool. Thank you. Appreciate it. This is like.
I just need a screwdriver for that.
Oh,
I'll be right back.
all right. Hey, I'm gonna go around and help out people. So I'll just put the
Okay.
I'll put the mic here.
Okay.
Okay.
So here is the QR code where you can find this exercise, okay?
In a position that I can see.
Okay. Yeah. I can lower this.
Ah, great. Now it's good. We are not suffering anymore.
Yeah.
Thank you so much.
Is that far enough? Is that good there?
It's good. I can change this now. Okay.
Cool. And then this, you can adjust it.
Okay. It's better now. It's better now.
Oh, yeah.
Okay.
Okay.
Yes. Okay. Thank you. Yes, we are asking to use the Wi-Fi only to the computers because cannot use with every now. I don't know. We need to ask for them now. Okay. They have it. I don't have it. Sorry.
Someone just get up the guests. That's my problem. I don't see any other things that are password protected. They both show us like password protected, so like Skylight guest password. Makes sense. Okay.
Check, check, 1, 2. Can you hear me? Hey, hey.
Just a quick check-in. If you don't have Wi-Fi, raise your hand. Who does not have Wi-Fi? Okay, 1, 2, 3, 4. 4 people, 5 people do not have Wi-Fi. 6 people. Everybody else has Wi-Fi, yes? Kind of. All right, cool. Stay tuned.
Hey, for those of you that are having problems with the Wi-Fi, come see me and we'll see what we can do for you. So, just come up and talk to me up here.
Good morning, everyone. Just want to say hi. My name is Darren. I'm one of the recruiters here at Chainlink Labs. Myself and Ryan Fitzpatrick will be in the back corner. If anyone's interested in a potential opportunity, either now or in the future, I'd love to say hi and connect. I'll let you know you don't have to have a background working in crypto or blockchain yet. We're happy to talk to you about a bunch of roles that we have. So I'm Darren, and Ryan will be in the back if anyone wants to say hi and talk about any jobs. Thank you.
Hey everyone, just 5 more minutes, wrap up this exercise and lunch, and we're gonna move on to the next section, all right? So 5 more minutes, I'll be back up here. All right, everyone, we're about to move on to the next section. So if I can get your attention up here. If y'all can quiet down a little bit, we're going to be going on to the next section. All right? Perfect. Thank you. Y'all in the back, can we quiet down just a little bit, please? Thank you. All right. So where's the... Okay, cool. All right, so in the first section, we talked about Chainlink data feeds, right? Getting this decentralized data on chain. And the reason we needed that data is because blockchains can't connect to external data on their own. And so we use a decentralized Oracle network to get that data in. But another thing that blockchains can't natively do is get randomness, secure randomness on chain. For the same reason that we can't get that data, because blockchains are deterministic. And in this case, we want the opposite of deterministic. We want something that people cannot predict, right? We want randomness, unpredictable randomness. And this is where Chainlink VRF comes in, verifiable randomness functions, right? So you could have a, let's say a raffle smart contract, right? That's giving away an item of value. Like maybe it's a very valuable NFT. And you want a random number to randomly choose a winner of that contract. And you want to ensure that your users, that is truly random, that there's no colluding going on by the creators of the smart contract or the miners or anything. So you say, okay, I'm just going to, once again, just trust a random number generator somewhere on the internet and have that deliver data onto the blockchain, right? Well, if you do that, that random number generator could be tampered with, right? The person could say, hey, I see, I want that NFT, that $10,000 NFT, I want it. So I'm only going to send a number that allows me to win. We don't want to take this decentralized system and trust a single person again. Right? So this is where Chainlink VRF comes in, and the magic is in the cryptography behind Chainlink VRF. So Chainlink VRF uses the Chainlink network and delivers a verifiably random number on chain. So it doesn't just give a random number, it gives a random number with a cryptographic proof that that number was indeed random. The inner workings of how it works is quite complex. There's a great article and blog post on blog.chain.link on like the exact cryptography and the mathematics behind how this randomness generator works. If you're like a really math-minded person, I highly recommend you read it. So VRF is being used all over the place, right? And one of the most popular places is in NFTs, like just like in the example I gave you. So you could have an NFT like card pack, essentially, and you know, distribute those cards in a random distribution, right? So maybe you have one ultra rare card NFT that you want to give users a 1 in 100,000 chance of getting, right? You can get your randomness and code up the logic so that is indeed random, right? And so there's projects like Avagochi's that are using it. You can also use it to generate the like actual stats of those NFTs, right? So this is a project like I've done before. Patrick has worked on having like Dungeons and Dragons characters that are generated with random stats, right? I think that's pretty cool. And you can have one or two of those stats be random. All kinds of cool stuff you can do with it. And I also want to make an addendum, like, I said, blockchains are deterministic. That's why they're not good for randomness. There are ways you can generate randomness on a blockchain, but they are not secure. And they're 100% gameable, and they will be gamed because everything on the blockchain is transparent and is deterministic. So, if you're leaving an attack vector open in a system like that with money, it will get attacked. And so let's just walk through a quick demo. Let's learn by doing. Woo! Nice. Yeah, come on up. So Solange is going to help me navigate while I explain things. And this is super exciting because just yesterday, VRF got upgraded to a new version with a bunch of new features and a bunch of new stuff. It was like brand spanking new, hot off the presses, and y'all are going to get to experience the next level of randomness on blockchain. Woo!
Yes. So an important point now, I'd like you to do this with me. So prepare your computer. Let's go.
You want video?
So I'm going back to the pad just now. Here. No. Okay, great. And let's go. I need to pick up my notes in the other side. And then I come back here. And we are use the new version of the VRF, like Zach said before. And I will add some links for you before I started. Until here. Wait. Wait. Here we are. So I added some links over our pad, but this is the basic, okay? The links related to the VRF, how if you already know something about it, how to change your smart contract from the version 1 to the version 2. And we are using this that I'm opening now. Wait. And remember that Zach was showing the data feeds. He is trying to go to this page. We have it now. And let's put here the VRF page. So we are doing this, how to get a random number. I know that you already have MetaMask, you already have Ethers on Rinkeby, you already have Link on Rinkeby, so we can go directly to the VRF page. And this is the VRF page. Are you open? Like you? And let's close some parts that I don't need now. Here we are. You can see over there that it's trying to identify my MetaMask wallet. It's already identified. Probably for you, you have a button here in the top corner, right? And you need to connect your wallet, okay? I don't have this button because I am already connected. But I change my network. You can see that I am on Coven. I'm going to Rinkeby just now. And now I am in the right network. Yes. And we are in the same page because in this account, I didn't create nothing. To use the VRF version 2, we need to create a subscription. I will add some information in our pad to you follow with me. Here we are. So we are already connected. What's happened with the pad today? And you click create subscription. You can see here that the subscription address is the address of my own account that it's already connected. And here I'm only create the subscription. I'm sending a transaction to the blockchain using MetaMask. You approve this. Confirm. It will be very fast here. I hope so. Yes. So I have the hash of the transaction confirmed. So now I am, my account has a subscription of the VRF. I can close or see the transaction or only close, is the same. Yes. After this, we wait a bit more to get this confirmation be here. So because of this, I don't have this button allowed before. And in this subscription, this is a difference from VRF1, because in VRF1, you need to add link to pay each time that you would like to generate a random number, but you are paying for each contract that you are using. So you need to add the links in your contract. Now in VRF2, you only need to add link to your account here. It means to your subscription. So let's do it. I defined here how much link I'd like to add to my account in VRF. I'd like to add 3 links. 3 links. Then you can click on add funds. And this is another transaction that's going to the blockchain. And confirm. Not yet. Now is. We have the transaction. We are waiting that the confirmation arrived here in this website. Okay. I'm changed to 3. And the next step is to add a consumer. Let's understand this better. Add consumers. This is our smart contract. So one subscription can have many consumers. Each consumer is a smart contract that you are using to generate the random numbers. This is very interesting here. I will not finish this page now. What I need to get here, I need to get this number, the subscription ID. So for me, this is the 333. I will save this number. So save your number of your subscription. Put in some place because you are using this in a few minutes. In the same way that we did with the data feeds that we are using an example from our documentation, you are using another smart contract now. Now I'm going to this link and let's go to the right place. I am here, okay, in the documentation. And if I scroll down and down and down, in some place, I have the smart contract. This is the smart contract. And in the same way that we did with the data feed, we can click the button Open in Remix. I know that I have a remix open already, okay? But I'm doing again because someone could start now. I close the other version. Yes, here we are. Remember that you need to find the smart contract. Where is it? Here, we have the code sample. This is a directory in our repository. So I go to docs.chainlink.link samples. We already saw the price feeds. Now we are going to the VRF and the VRF v2 consumer. This is open in this site. And let's understand what we have in our smart contract, but I need to see this error. I cannot do this. Probably I need to refresh my remix, so I will do this in a few minutes. Let's explain for you first. Here is the same. We have the license. We have some comments. This is very well commented, so it will be easy for you. I am importing some libraries, some smart contracts from Chainlink, like the link token interface, because we are using the link token, the VRF coordinator interface, and the consumer base. This is my smart contract. It's called VRF v2 consumer. And I'm using some parts of the VRF consumer base v2. I need to have the coordinator, and this must be the interface that I imported before. And I already need to have the link token interface, and I have it here. Remember that subscription ID, I will save this here. And I'm defining some parts because we are using Rinkeby, so this is done for us. This is easy. And you need to define the callback gas limit because the VRF runs in a different way. So you are calling the VRF, then we need to wait a bit, wait a few seconds, and the VRF, you return to a function in your smart contract the result. Like this. I go down, I am requesting here, request random words. Words for us, it will be a number. Don't worry about it. And when the VRF has our numbers, you call this fulfill random words. And the numbers are returned to this function. Okay? Remember the only owner that we saw in our first smart contract? It's here again. And is this, we talk about the constructor in the beginning. Remember that the constructor is called only when you are deploying the smart contract. And I have here all the definitions that we need. And I think it's this. We can do. I need to refresh. You know that my remix is a bit crazy today. but I like it. I really like the remix. It's doing, let's try, let's go. Yes, remember that I have the auto compile selected, so I have the green button over there. It's compiled. I'm so happy. And I'm going to the fourth icon. Change again because I just refresh. I need to connect it with my wallet again. Hinkeby, it's perfect. 790. I know that this is my wallet. And pay attention here, okay? You need to select the right contract. We need to use the VRF V2 consumer. And remember your subscription ID. It's here. You are using here to deploy your smart contract. Let me check if I need to add more information for you in the pad. Yes, we have more information over there until we deploy the smart contract. Are you deploying my smart contract just now? Let's approve the transaction. Confirm. Wait some seconds. I am looking down and it's already confirmed. So let's scroll down and I can see that I have my smart contract here. But now I need to come back to the VRF page and add the consumer in that page to be used. So I will copy the address of my smart contract. And you can do this with me. Go. In a few minutes. Oh no. I'm so happy that we have a lot of persons. Name and address, okay? Like this is mine. VRF V2 consumer. You can put your two. I can watch your smart contracts later. And I will use this now in the in the VRF application. So I come back to the vrf.chainlink.link, and you are waiting this page that we have the subscription ID, and then I will add the consumer address over there, and now it's able to add the consumer. Let's approve this transaction on MetaMask again. Confirm. Come on, okay. Wait a few seconds. And after this confirmation, I am able to request a random number. But there are some points that I'd like to explain for you. In the VRF V1, we can only ask one number per time. But now in VRF V2, we can ask more than one. And here in some, here, I have the num words. Remember that words for us, it's a number just now. And I'm requesting two numbers just here. And this is returning an array of numbers. Remember that you learned about the arrays? We have an arrays of strings. Now we have an array of numbers. And because I have my smart contract here active, I can call the VRF in the remix. So let's come back to remix, scroll down, expand my smart contract, and I will use this function request random words. So I'm asking the VRF to give me numbers, random numbers. I'm sending a transaction. Let's confirm it. Yes. In a few seconds, we will have this confirmed. Wow, it's so fast in this time. But this is very important. Okay, it's confirmed. If I go just now here, can I see the random numbers or the request ID? Yes, I have it here. Let's check the numbers. Remember that I have two numbers, so I will query these numbers by the index just now. Index 0, not now. And why I don't have this number not now? Because I need to wait a bit. This request ID, it means that I asked the numbers, but the numbers didn't come back to my fulfill random words function. So I need to wait a bit more, maybe now. Let's try again. Not now. I can see that I have an error. So I need to wait a bit more. Let's wait. Try again. No. And I will copy more information for you in the pad, only to be sure that everyone has the information. Wow, we have more persons doing with me. Wow, very well. Daniel, Sandy, Tyler, Bruce, Brian, Joseph, Mauricio. This is amazing. What is the last? Okay, expand to find the file. Okay. Wow, we have more numbers now, more persons that deploy it. This is great. I really like this. And now we have this, we already did this part, and we did the part in remix, and we are waiting. Probably it's done now. Let's go. Random words, 0? Not yet. So I need to wait a bit more. Let me check if everything is here. Yes, the information is here. Not yet. Here I can see everything. I'm still waiting. Let's change. No. Okay, I'm waiting. But guys, would you like to explain why I need to wait this? Why VRF is different? Zach, come back to help me, please. Yes, no, I think you can explain this better than me. Why we need to wait the VRF function? Like I did your request and I'm waiting. Why I need to wait? Explain for them, please.
Yes, no problem, Solange. So yeah, so in the blockchain, the way the consensus algorithm works, the way the blocks are built, you have what's called probabilistic finality. Now that sounds like very complicated, but each new block, like if your transaction is included in a block, each new block that comes after it solidifies the block your transaction was in a little bit more, right? So if a transaction gets put in a block and it's only no block is in front of it, there's a chance that there's a fork in the consensus algorithm, which means some of the nodes have a different block and they take a different value. And so with VRF, to assure that, you know, we are not getting our value forked out of the blockchain, we give it some confirmations. We wait for a couple of blocks to be built in front of the block that the transaction is included in. So that's called a reorg, by the way. So a reorg doesn't happen. And this just gives you more assurance that like you won't have a reorg attack. So in VRV2, you can actually customize how many confirmations you want to wait. I think like minimum is 3 and max, it's somewhere like, I think 300. You can look in the docs. We'll go through that in a bit, and it shows you what the max amount of confirmations, but that's like highly secure. If you wait like a couple of hundred blocks, like the chances of your transaction getting kicked out are like 1 times 10 to the negative 26 or something, you know, ridiculous. Like there's no way it's going to happen at that many blocks statistically. So yeah, that's kind of why we have to wait.
Thank you, Zaki.
Take it away, Solange.
Oh, wow. It was amazing. I really love your explanation. And like Zach said before, here we are defined that we are waiting for 3 confirmations, okay? And this time it was perfect because now I have here the random words. The word 0, it's our first number. I know that this is a bit difficult to understand, but the final is 34. Let's go to the word 1, or the number 1. We have another number here. The final is 35. I can do this again, request another ID, and this you get more time. You can do this. I will not wait here to do this again. I think you understand better. I will only ask a new number. And then after this, you can do the same and see the results by yourself, okay? I will request a new number now. And this part related to VRF is done. So now Zach has come back to talk with you about keepers. Oh.
Can you put it back on the presentation? So before we move on to the next section, I'd love to give you all an opportunity to ask some questions. So if you're curious about anything, it could be VRF, some of the previous stuff we talked about, anything Solidity, Chainlink, go ahead and open the floor to some questions. Everyone all good? No curiosities? Yeah. What's up, man? Exactly. So he asked, can you increase the number of random numbers you asked for? And this is actually a feature new to VRV2. And VRV1, you would send a request and you get 1 random number back. And you could code some programming scripts that would split that random number up into more random numbers. But now natively in VRV2, it provides more than 1 number. So exactly, in that field, you can say, hey, I want 10 random numbers and get that and store it. Anything else? I mean, this is cutting edge stuff, guys. Like, don't be afraid. Yeah, so again, you know, if you want to connect your smart contract to, I don't know, randomnumbergenerator.com or something, you have to trust that website to provide a random number that they didn't tamper with. Because the blockchain is transparent, anyone could look at that smart contract code and see what's going on, and that random number operator could just provide a number that works in their benefit. So in the example of the raffle, you know, if they look at that smart contract and they say a raffle worth an NFT is being raffled off, and that NFT is worth $10,000, right? Perhaps they just put a random number that gives them the NFT, so it's not really a random number. With VRF, a cryptographic proof is included with the random number that proves mathematically that that number wasn't tampered with. And when the random number is put on chain, the proof goes with it, and the entire blockchain verifies that that random number was indeed generated randomly. Does that answer your question? Great question. So he asked, what is the range of the random number that you can get, right? So the random number comes in as an int 256, I believe. Not uint, yeah. And that's a 256-bit length number, right? So like it's like 1 times 10 to the 26. It's a really large number, right? And so anything within that range you can get, and then you can create like modulo functions and stuff to split up the number even more if you require. But with VRV2, you can just request more random numbers. Yep.
The cryptographic proof, does that come from the Chainlink nodes? Like would they be doing the random number generator that somebody would try to do themselves, but then behind their kind of private public key signature, and then that proves it? So it would be similar functionality, but it's not you as the single point generator.
Exactly. So the gentleman asked, how is the proof generated on the Chainlink side, right? So yeah, the Chainlink node generates the random number, and there's this whole cryptographic algorithm. It's pretty complex, above my pay grade for sure. But there is a great blog article that explains like the math. If you're like a super math guy and you want to know exactly how that proof is generated and what the math is behind that, I really suggest you read it. You go to blog.chain.link and you look up VRF. You'll find an article explaining that. But yes, the Chainlink node side generates the random number and the proof, signs the transaction, and sends it onto the blockchain. Yep. Anybody else? Oh, wait. Andy in the back. Oh, this gentleman right here. Yes. You could set something up to do that. The example that we have right here, just anyone who calls that random number. But what you're doing is you're putting the consumer contract on the subscription, right? So you would have to approve the other contract on the subscription anyway, right? So only because Sol only had her consumer, the contract getting the random number on the subscription, only that contract can call the VRF and spin the link. Now, if you want other people on there, you can add other contracts, other wallets, what have you. But yeah, that's how that works. Yeah, that's totally possible. The cryptographic proof behind it, helps prove that it was random, but you can. It's very hard to do that. There's 100,000 nodes, tens of thousands of nodes on the Ethereum blockchain, right? So to do that, they would have to collude with almost all of those nodes, which is like statistically impossible almost, right? So it's very unlikely for that to happen. But it is statistically like possible, but very unlikely.
Got a bunch of rare NFTs to go sell on the market for more than they come. So these are hypothetical scenarios, the real attacks that people are doing, that your VRF solves because it's secure that brain.
So for the folks online, what Andy was saying is that this stuff is being used. There's projects using it. A lot of NFT projects use it to distribute traits. More rare traits, have a less chance of being distributed. Yeah, it's being used all over the place, especially in the NFT space. So thanks for that, Andy. All right, so if that's it with the questions, We can move on to Chainlink Any API. I think that's next. Or it might be Keepers.
Yes, you can go to that site. And I prepared this for you. Wait a minute.
Are you going to do another exercise with this? You
No.
want to do it? Okay.
No.
Where will you do this one?
Yes, you can.
Okay, we got Keepers.
we did. So now it's Keepers.
So we got Keepers.
So
we've talked about getting data, price data from outside the blockchain onto the blockchain. We talked about generating random numbers, putting that on the blockchain. What are the other limitations of smart contracts on blockchains without Oracle systems? Another limitation is someone has to call a function on a smart contract to run it. Right? You've been running these functions all the time. You do it from your wallet. But what if you just want a smart contract that kind of runs autonomously? That runs a certain function every hour, every day, every year. That's when you need an Oracle, a decentralized Oracle network called a Keepers network to come in and run those functions. So Sol actually did a very awesome talk earlier in EthDenver, going over Keepers and like going through a demo. So for the sake of time today, I'm not going to actually go through a demo of Keepers. I'll just refer you to that video, and if you have any questions, of course, come to me, but I will explain how Keepers works and answer any questions you may have about it. All right, so again, smart contracts can't call their own functions, right? Without someone externally initiating it, initially sending that transaction out and starting the chain, right? So again, you could have just some centralized server that has some kind of autonomous cron job running and it calls that method and you trust that server. But now, once again, you're trusting this one single entity to do something for you when you have this whole decentralized network. And that's not good in the blockchain world, right? We're doing all of this because we like decentralization. So I'm gonna say decentralization like 5 million more times throughout the talk. If you're in EthDenver, you're never gonna stop hearing it. That's what powers this world, right? So the Chainlink Keepers is basically essentially a DON that automates the calling of smart contract functions, right? So you have a bunch of nodes. They monitor smart contracts that are registered with them, and they call a function when requirements are met, like whatever the requirements may be. Right, so one example use case is liquidating under collateralized loans. That was a lot if you're not in DeFi, but essentially in DeFi, right, a very popular borrowing and lending application. Borrowing and lending is very popular in DeFi, right? And you can lock up collateral to print, usually a stable coin or whatever, and you can go leverage on it. But the thing with these loans is they have to be over collateralized, right? There's no really inbuilt credit system in the blockchain right now. And if those loans fall below a certain collateral level, someone needs to come in and say, this loan is bad, it's under collateralized, and we're going to liquidate it. Because the system will fail if those liquidators don't come in. And so without a Keepers network, you're just trusting that people are going to come in and you're hoping that they're going to liquidate those loans. And we've seen times where that doesn't happen. There was the infamous, Black Tuesday in 2020 when gas prices went crazy and a bunch of loans that were supposed to be liquidated didn't get liquidated, and systems got a little wonky there. The blockchain space recovered, of course, and here we are today. But of course, we've built more robust systems to handle this. So now you can have a decentralized Keepers network, monitor those loans, and immediately when they say, hey, it's under collateralized, they're going to run that job. They're going to liquidate those loans. And so that's what this diagram is showing. It's showing that and Aave, which is one of those borrowing and lending programs, DeFi apps, which, by the way, they also use Chainlink data feeds in the back end to get their price data for that lending. So that was Keepers. I'm going to keep it short right there. Again, if you have any questions or you want to mess around with it, yeah, I'll take a question right now. That's a good question. I'm not sure on that one 100%, like what the implementation details for MAV are. Let me get back to you after this. Good question, though. Anyone else? Yeah, go for it. If you, yeah. Sorry, what was that? Well, the thing with flashbots is you're giving someone the ability to arbitrage that transaction. So that isn't so good either. Like, we don't want to just give away transactions and let people take advantage of that information asymmetry that they have and do that. There's actually a Chainlink service in the work for protecting against MEV stuff like that, called Fair Sequencing Service. It's still in development, but that will kind of help solve MEV. Now, so yeah, at the node level, we wouldn't want to give transactions to flashbots for that reason. Any other questions on keepers, automation? All right. So is anyone here participating in a hackathon coming up? Patrick. Yes, awesome. So we got a couple of hackathon participants back here, right? This next product is, this next service is very, very popular with hackathon participants, right? So this is any API. This allows you to connect your smart contract to any API, right? And it's a very useful project for MVPing a project you may be working on, right? So this is a kind of centralized service. So a lot of times this doesn't go into production, but creating a DON, if there's not already a DON you can utilize, can be a lot of hard work if you're just trying to MVP your project, right? And so this is why we see a lot of hackathons use any API. And so, yeah, let's talk a little bit how it works, right? So in this case, we have a marketplace of Chainlink nodes. You can find them on a marketplace like market.link. That's one of the most popular, but anyone can host a marketplace of Chainlink nodes. And you can select one of those and have a generalized job that says, hey, this node will send any kind of HTTP GET request to an API somewhere and return data from that API, right? So if you're a developer that's done any kind of full stack outside of Web3 development, you'll be very familiar with this like API call workflow, right? And you can have nodes that do very specific types of data. Like you have nodes that go up and all they do is return weather data. And so the power behind this, how these nodes work, is called Chainlink adapters, right? So adapters allow the Chainlink nodes to be infinitely flexible in what they can do, including where they connect to, right? So if you have a API that has some kind of price data or weather data, and that API requires a key to get in, right? You can't just have any node go in and connect to it. They need to get an API key for that API. They need like that secret password that lets them get the data. And in an adapter, you can program it so the node, has that key. It can access that data and get that data source from that API. And the cool thing with that is too, you can do all kinds of cool computation that the Chainlink node might not natively have. So the Chainlink nodes have a bunch of pre-built tasks they can do, get data, parse that data, maybe take a median of that data, but maybe you want some crazy, averaging, volume-weighted average thing going on. You can do that with Chainlink adapters on the node, right? And so this is that Chainlink market I was talking, market.link, where you can find a whole bunch of jobs. You can also find some default jobs run by the DevRel team, which is the team I work on the Chainlink docs. So at docs.chain.link, if you go to the any API section, you can find some nodes there you can use for your projects. All right, so now I'm going to demo any API, kind of like we did before. I'm going to go to the docs, kind of show you how it works, and go from there. Good to pull up docs? All right, yeah. Soul's coming to assist me again. Coming in clutch, Soul. Awesome. Yep. I think it's in the instructions. All right, so we're going to pull up the docs. This is a workflow I still follow all the time, right? The Chainlink docs are very good at explaining, what you need to do, where you need to go, and having just very simple tutorials step by step on what if you need to do any of these projects, or you leave here and you kind of forget what to do, go to the docs, right? There's even very beginner tutorials there. If you forget how to set up MetaMask, there's a tutorial for setting up MetaMask, and getting to those faucets to get those coins. Those are on there as well. So definitely docs is a very useful resource as you grow as developers. It's okay if you just go to the docs. Yeah. So while this is pulling up, does anyone have any questions on any API and how that works? No curiosities? I hope I see some of you using it in your hackathon projects going forward, because I'll be judging for the Chainlink bounties. So if you didn't know, we're taking part of the Bill of the Week. We have 4,500. We have a grand prize $4,500 bounty. So just a person who uses Chainlink in their product to make a state change on chain. So not just using it in a front end, but actually using it with a smart contract. The top project, just judged by UX, UI, creativity, skill and programming, can win 4,500. But not only that, we have 8 runner-up projects winners that can win $1,000, and that's for in-person. Online participants have the same deal, so they can win $4,500 grand prize or $1,000 runner-up. So, yep, that's perfect. Make a GET request there. Yep. All right. Yep. So we're going on the docs on the left side, right? So we're going to any API. That's the solution we're about to use. Connect to any API. I'm going to say make a GET request. This is one of the most kind of simple examples you can use. And this is just saying, hey, I'm going to make a request to this data provider, this source, this API. I'm going to say, hey, I want to get some data and pull it in, right? And so we go to the docs. We see that nifty remix example that we saw earlier when we were going through data feeds, and that open and remix button. So we're going to click open and remix. Remix is going to take its time and load. But it'll take that whole example and place it in there. Now, something interesting about any API versus feeds, for example, is with feeds, you could just read the data, right? You just clicked on that get latest price and you got it. In any API, you actually have to fund the contract with Link. This is a very important step. The contract needs Link in it to send to the Chainlink node and pay that Chainlink node for its work, right? So just like in Ethereum, you pay ETH gas fees in ETH, and Link, you pay Chainlink nodes and Link token for the work that they do. Yep. So now we're looking at the any API smart contract. And again, you see our Pragma Solidity saying what compiler version you're using, and you're seeing that import statement, right? The import statement is all you need to connect into the Chainlink network in your smart contract, right? So in this case, before we had aggregator v3 interface and feeds and random number consumer. This time we have, can you scroll up? This time we have Chainlink client.sol. So that is the import you need to have to access the any API service. And in this case, we have a couple of state variables we're setting up. We're going to try to get the volume of ETHUSD on a particular data provider, right? So just like in data feeds, where we had to change our address to point to different contracts that took in that data, right? This case, we need to tell it what oracle we're going to point to, what specific node we want to point to. And nodes can have multiple jobs. They can do multiple things. Like they can have one job that gets weather data, one job that gets price data, all kinds of jobs, right? And so in this case, we're going to say, hey, we want this oracle, 0xC57, blah, 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 and this job ID, right? And this job ID will get the volume of ETHUSD. Now, if you're curious, how do you know a job ID? Well, it's written in the smart contract here, of course. But if you go to market.link, you can see, you can find various nodes that are running the Chainlink software and see what jobs that they have available and what those job IDs are and what those oracle addresses are. So, if you want a GET request one, go market.link, find a node listing that has a job for a GET request. So we have one function here, request volume data. Let's walk through this function and just kind of see what it's doing. So it's called request volume data. It's a public function. Anyone can call it, and it returns a request ID. This function is literally, as it says, it's going to send out a request to the Chainlink node, right? That's all this function is going to do. And we're building the request here in line 47, request that add, get, and now it's saying, hey, make a GET request. Tell that API we want to get data, and this is the URL for that API, right? So in this case, it's cryptocompare.com that we're going to be getting some volume data from. Now we have to add the path, so we have request.add path. So typically APIs return data in what's called a JSON format, right? Which is basically just a list, like a bunch of key value pairs. And we're going to tell it, hey, look at that list and go to this raw, look at the value there. Okay, then that value, within those values, look at ETH. Then go there. Now find USD, and so on, break down until we get to volume 24-hour and get the value listed to that key. And yep, then we're just going to take that value, we're going to multiply it by a specific amount. In this case, 10 to the 18. This is to remove decimals in the way Solidity works. And then it's actually going to make that request and send it out, right? So boom, we're done, right? We're good. Not quite, right? So now that the Chainlink request has gotten the Chainlink node has gotten its request, we need to wait for it to respond. And we need to tell it what to do when it responds. So we have this other function, fulfill, right? And it's going to take the request ID, which was generated when we sent the request, and it's going to accept that volume number. And in this case, all we're going to do with that data is we're going to store it in state. We're going to store it in that volume variable we had at the top of the contract. So it'll just be stored on the blockchain until the next time fulfill is called, and that value is overwritten. All right, so let's go ahead and learn by doing. All right, so again, we'll switch to injected Web3. So we're communicating with a testnet, and RinkB is up there. We're going to switch to Kovan because that's what the node is. The node we're talking to is on Kovan in this case. And again, make sure we're pointing to the right contract. This step gets me literally every time. And it's all the way at the bottom. Yep. And we should be good to go. Our code compiled fine by that green check mark on the left. So we can go ahead and deploy. MetaMask is being a little slow today. All right, so we'll confirm. And so that transaction is going to go through, and the first thing we're going to do is we're going to send out that request. We're going to run that request function the minute it runs. No, why not?
Because we need to fund the contract with Link.
Exactly. I can't tell you how many times I haven't funded that contract with Link. How many times I've seen people not fund that contract with Link. Happens all the time. Just let's show them what happens when you don't fund it with Link, right? You're going to get a very generic error. So request volume data, yep. We're going to click request volume data, and you're going to get this error, gas estimation failed, which basically means anything, right? But in this case, it's because we didn't fund the contract with Link, and it didn't know what to do with the computation in the back end, right? So let's go ahead and fund that contract with Link Soul.
So remember that you can copy the address over there and then go to your wallet and send some link to this wallet. I am in the assets, and it's supposed to have the link token here. Yes, it's here. So I'm going to the link token and send. Paste the address. How much?
Let's just send one link.
One link, okay. And then next, and confirm the transaction.
So real quick, how did I know one link would be enough for this request, right? So while we're waiting for the node to respond, on market.link, if you go there, any node will also list the price of link to complete that job, right? We know in this case, because this came straight from the docs, if you scroll up in the code, actually. Yep, down a little bit. Yep, we have this field here in the constructor called fee. Is 0.1 times 10 to the 18. That's because Solidity doesn't do variables, decimals. What that means, that's just 0.1 link, right? It costs 0.1 link to send a job. If you put less than 0.1 link in that contract, it will fail. It won't send the transaction through, or the node won't respond, right? So make sure you set the link price correctly. So she sent out the request, right? Yep, so we're sending out the request now, clicking request volume. MetaMask just gotta be slow today. And now that transaction is gonna go to the blockchain. It's gonna be mined by the blocks, right? And we have to wait for that to be confirmed. Then the Chainlink node senses, hey, this transaction has been included and blocked. It sent out an event to me. I need to respond with that data, that request it's asking for. So now we have to wait for the node to respond, right? So it needs to make a transaction on the blockchain. Its transaction needs to be included in the blocks. Then our value will be updated. So right now it's still 0, and boom. We got a request. In this case, the volume is this really big number, which makes sense. It's ETH. It's super popular. And that is any API, right? So again, if there isn't a DON already made for a project you're working on, and you just want to work on a hackathon project and see what kind of cool logic you can make with external data, any API is great for that. Yeah, in the hackathon, you say, I want just some weird out there data. I want to know how many donuts were sold at Krispy Kreme on a Thursday last year. Connect to the Krispy Kreme API and get that donut sales number, right? So yeah, you can get really cool with any API. Any questions about any API? If not, we'll break for another exercise here in a bit, and I'll let y'all mess with any API. Me, Patrick, and Sol will come around and help you out and answer any tech questions you may have. Oh, we got Andy coming up. Sure, Andy has a request.
I might come and ask you to come and chat with me. I'm going to do just some quick interviews with Chainlink Labs team members as well as people participating for when we do an edited version of this. Just, what do you think about the bootcamp? What are you getting out of it? What are some things you learned? So if I come up to you or if you want to come talk to me, I'd love to chat with some people for the rest of the session here and there. So heads up.
Andy is super easy to talk to, super easy to interview with. He'll make you look good on camera. Thanks, Andy. Yeah, that would be a cool feature. But any API was one of the first Chainlink services out, and a lot of the other Chainlink services are built on it. And usually any API is just used for, like I said, MVP projects, hackathon projects, and stuff like that. But that'd be a cool hackathon project, do a subscription service for any API. We got to please build that from Patrick. He's about it. All right. Well, if there's no other questions, we'll go ahead and break for the any API exercise and come around and help you out. So let's get coding.
Anybody knows how long is this break? Zach and Patrick, do you know? I try to discover it for you.
We'll have about 20 minutes on this exercise, folks. So 20 minutes.
Can you play that again?
And during this period, if you all want to just make sure those setup instructions are followed through and that you have Node and Yarn set up, that'll set you up for success. So do that.
Hello, hello. All right, we're about to move on to some really interesting stuff now. How to program in Hardhat, a local development environment. And this is really how most professional like DeFi blockchain companies develop smart contracts, locally with these frameworks that make things easy, right? So let's talk about it a little bit. Just a little reminder, part 2 of the bootcamp. We're going to talk about local development. Part 1 was kind of intro. We talked about Remix. We used Remix a lot. Talked about Chainlink, how to connect smart contracts. Had some lunch. Now we're going to do local development. All right, so we're going to introduce what development environments are. We're going to talk about the Chainlink Hardhat starter kit and the Chainlink starter kits in general and how you can use those. Working with local networks. Brief on smart contract security and keeping your smart contracts safe, and how to test your smart contracts. And then we'll have some closing statements, and that'll take us in through the rest of the afternoon. And if you stay to the end, we'll have a little link for you to fill out for feedback and also for POAPs. So if you want to prove that you were here. All right, so again, just to recap the rules, if anyone forgot, if you're online and you're watching this, go to the Discord and ask for technical help there. Our TAs have been great. Shout out to Harry, Richard, and Andres for holding everything down, and Melody as well. Really wouldn't have been as smooth without y'all. But yeah, and same kind of thing here. We'll talk, we'll lecture, we'll go through some demos and break for some exercises and come around and help everyone out. So what is the development environment, right? It's basically a tool set you download onto your computer to help you develop smart contracts in a more efficient way, right? You can have a whole bunch of features built in there. Up until now, we have been using Remix development environment, or IDE, integrated development environment. And it's web-based. It's got a bunch of cool modules, as you've seen. You can compile, you can deploy, you can add in a bunch of plugins now. They're actually improving a lot and becoming a pretty powerful online IDE. But still, a lot of true smart contract development is done in a local environment, right? So what are some limitations of Remix? You can only deal with smart contracts. It's hard. You can't really write any scripts to automate things and automate your deployments. It's hard to connect other parts of projects together and keep track of all your files. If you have more than a couple of contracts, it can get pretty tough. You know, you can't really save files locally. It saves it in like cache and other things, but you know, you're not saving those contracts into your local disk. And any custom functionality requires a plugin. It doesn't just come like native with a lot of functionality, right? So that's where we get a development framework like Hardhat. So Hardhat is a JavaScript development framework, right? It allows you to compile, test, debug your code all through your local machine. Like you could do all of that without an internet connection until you need to deploy, of course. Once you get used to it, it enables easy integration of code and external tools, and it's just really a very extensible, powerful tool. There are other like development environments. So if you're like more Python focused, a really popular one is Brownie, and that's also very powerful. Patrick is going to be coming up and walking through Hardhat a lot, but he's actually a huge fan of Brownie as well. So he's a big Python developer. I'm a big JavaScript developer, so I work in Hardhat, and we agree to disagree, right? So yeah, you have two kinds of main things in Hardhat: tasks and plugins, right? And these things can be used to automate whatever you need to do, right? So you can have a task that goes through and it's a JavaScript task, and all that stuff we were doing in Remix by hitting buttons, you just run the task, hit enter, and it'll do a bunch of things. It'll take your contract, it'll compile it, it'll automatically deploy it to a testnet, and you can even have it run some functions from the get-go. You can also bring in plugins into Hardhat for any functionality that isn't natively there, and they have a whole list of plugins, including support for web3.js and ethers.js, which are very fundamental JavaScript libraries for interacting with blockchains and Ethereum EVM-based blockchains. So with that, Patrick's going to come up. He's going to walk you through creating your first Hardhat project. So welcome, Patrick.
What up? How we all doing? Oh, I just broke it. Or did I? Doesn't want to agree with me, huh? Did I get it? All right, I think so. Can you all hear me okay? Am I too loud? Am I all right? Cool. So now, as Zach was saying, we're going to get into what I think is the best part of this whole thing, because this is how you're going to learn the professional setup. This is what the pros do. They use Remix. Or excuse me, they don't use Remix. They use Hardhat. So before I jump into anything, is there anybody here that doesn't have Node installed? Node.js installed. All right, Teresa does not have Node.js installed. Anybody else? And if you're like, I don't even know if I have Node.js installed. Well, what you can do is you can open up your VS Code or your code editor, and then who does not have a code editor? We all have code editors. Oh, Richard doesn't. Wait, you were using Vim. You have a code editor. You're good to go there. But you can check by opening up your code editor, opening up your terminal, or you can do that with terminal, new terminal. I'm doing Node. Hopefully y'all can see this, -V, and you should see something like this show up. So if you don't have this installed, raise your hand. Zach, Sol, or somebody will come around and give you a hand there. So you absolutely need this installed. In the exercise instructions, it also says you need Yarn installed. So hopefully this is zoomed in enough. I'm just going to super zoom in because I want to. Yarn-V, if Yarn is giving you issues. Oh, whoops. NPM works great too. NPM and NPX. So are we all set here? If we're all set, say aye. All All right, cool. We're all set here. Awesome. So this is going to be the most exciting part of this whole thing. Not to say the other, well, excuse me, this is going to be the setup that's going to give you the professional setup. Cool. So let's go ahead and jump in. So we're in our VS Code, and all the instructions for doing this are in that exercise sheet. But if you want to just follow along, you can follow along, and you'll get to see why this is so wonderful and why this is so helpful for our development environment. So if you haven't already, in your terminal, we're going to create a new folder. I do everything in like demos. You can do that with mkdir. I'm going to call mine like EthDenver. Actually, EthDenver. Did I already make this? I already made it. EthDenver. We're going to CD into that new directory, EthDenver. And this is where we're going to make our project. All right. We're going to make our brand spanking new Hardhat project where we're going to have this amazing development environment. And the way we're going to set it up is we're going to do yarn add Hardhat. And then again, if yarn doesn't work, you'll do npm install Hardhat. And I'm seeing a bunch of people not typing, which means you guys are already ahead, which is great. And then we're going to run yarn Hardhat. Or if yarn's giving you issues, you can run npx Hardhat. And you'll get something that looks like this. Who has not gotten to this point? Or, okay, we have a couple hands. Okay. If helpers are busy. If any, can I ask some of the people who haven't gotten here yet? What's going on? Oh, you're trying npm. Okay. Yeah, npx Hardhat should work as well. And then I'll come around after I go through this and help you all out. What we're going to do is we're going to choose an empty Hardhat config. And if we type like ls, we'll see something like this. I don't know if the ls command works on Windows. Sorry, I forget the Windows command. But what we can do is we can go File, Open Folder, and we'll go to that folder we just created and hit Open. And what's going to happen is VS Code's going to re-render. I'm going to say yes, I trust the author because it's me. And in this little thing on the side, we'll have, it's called our file explorer. We'll see all the files in this folder, right? So we have Node.js, hardhat.config, package.json, and yarn.lock. Or if you used npm, you'll have package-lock.json. So what's going on here? Node modules is going to be our dependencies. This is all the stuff that we need to run all of our JavaScript code. Hardhat.config.js. This is going to be all of our configurations for our Hardhat stuff. Package.json helps for dependencies, and yarn.log also helps for dependencies. I'm not going to go over that right now, but if you want to look into that later, you can. Cool. And now that we have that installed, the next thing that we're going to do is we're going to do yarn add or npm install. Yarn add, I'm going to do --dev at Nomic Labs / Hardhat ethers and ethers. Hopefully I spelled that right. And these are going to be packages that allow us to use the ethers.js package. Ethers is an incredibly powerful JavaScript-based package that allows us to like do Solidity stuff. And then we're also going to do yarn add --dev.env for reasons you'll see later. In our Hardhat config, actually, it's probably going to be easier for me to copy paste. So let me flip back and forth a little bit here. Yeah, okay. In our Hardhat config, we're going to be going for exactly this setup, and I'm going to explain what's going on in here so that we know what's going on. So if you're working off the workshop sheet, you can just copy this. I'm going to tell you what's going on. And if you're not working with the workshop, well, you better learn how to type real fast, real soon. So what's going on is at the top, we're importing or doing this require statement, this ethers thing, which is this really powerful package that we'll go through in a bit. We're also requiring .env for using what's called environment variables. Now, for those of you who have skipped ahead, you might have seen that we have we create what's called a .env file. When we're doing this stuff, we're smart contract developing, and do we want to share our private keys with our friends and with other coders? No. Why not? Because you're going to get exploited, right? Not your keys, not your wallet. So if we push up to GitHub or we share in some repo, hey, here's our private key, you're going to get rugged. So what we want to do is we want to stick these in a place that isn't going to be seen by other people. So we're going to stick our private key in a .environment variable. And we want to make sure that this .env file is never shared with anybody. Why? Because if you share it, you get rugged, and we don't want to get rugged. This is actually one of the reasons I do like the Brownie framework for at least for stuff like this, is because Brownie actually has a way to encrypt your .env files so that not even you can see it, which is really nice. But what we're going to do is we're going to stick in here our private keys. So this is a burner wallet of mine, so I don't really care if y'all steal from my private key. I have some testnet ETH in here. I mean, it would be better if you didn't steal my testnet ETH, but you know, if you do, it's not the end of the world. So I have like the tiniest bit of Coven. Please don't steal my 0.1 Coven from me. So what I'm going to do in this account is we're actually going to grab our private key from this account here. So we're going to hit these little 3 dots. We're going to go to account details, export private key, or type our MetaMask password, which again, because it's a burner wallet, my password is awful. And boom, now we have our private key. So what we do, we take this private key and we can now stick it in our .env file. So we'll do private key equals, boom, right like that. And then we save. What does this do? This now gives our, actually, and for some packages, you might need to add the 0x at the start. I think Hardhat is actually smart enough to know that you don't need the 0x, but you can just be safe, add the 0x at the start. So boom, now that we have this private key in here, our Hardhat package knows, okay, this is the account that I can use, because again, you need your private key to sign all your transactions. So cool, so we have a private key, awesome. What else do we need? I'm actually just gonna flip back and forth on here. Oh yeah, it showed you how to do all that stuff. Next thing we're gonna need is a Coven RPC URL. This is gonna be your blockchain connections. Whenever you sign a transaction and send a transaction, you need to send it to a blockchain node. This is the blockchain node that we're gonna send it to. Interestingly enough, when you're using Remix, there's actually one of these RPC URLs in your MetaMasks, which is kind of cool. So we're doing the exact same thing. I already have mine set someplace else, so I'm gonna skip this step. Now, what we're gonna, all of our contracts, all the professional contracts are usually in a contracts folder. So we're gonna go ahead and create a new folder, contracts, and we're gonna create a new contract called mycontract.sol. And this is where you put whatever you want. This is where you put your Solidity code, right? And so I think we have a real simple contract here. Paste it in, boom. All it does is store your number. Set number, get number, that's it. And now that it's in here, we can do all the same things that we were doing with Remix, but in our terminal, like in our local development, in our local development. So if I want to compile this, I would do yarn, Hardhat compile, or if you're using npm, you'd use npx Hardhat compile, and we'll hit enter, and it'll go ahead and start compiling for you. Boom. And now you'll see we have this new artifacts folder. This is where all like the low bytecode stuff is compiled, right? So you can go in here, we can see, you know, I have this myfirstcontract.json where it has all this stuff. It's got your ABI, it has your bytecode, deployed bytecode. Not a whole lot in here because obviously it's a pretty easy smart contract. And now what we can do is we can create a deploy script, which will have us deploy it. In Remix, you just hit that deploy button, which is great, but in our professional environments, oftentimes we want way more modular control over how we deploy stuff. right? Maybe it's just not as easy to deploy button. Maybe we want to deploy based off of the weather, based off of the day with some weird parameters. We want to have that modularity. So what we do is we'll create a new folder called scripts in here. Scripts. And we're going to create a new file called deploy.js. And this is where we're going to add our deploy script. So this is where we're going to add our customization. And this is also, I'm going to zoom out just a little bit so I can copy paste easier. This is also in this little worksheet, so I'm just going to copy paste. But let's talk about what this is actually doing. What's going on here? So we have this deploy function, or excuse me, this main function, which gets called in JavaScript. And for those of you who are not familiar with JavaScript, this gets executed first, and it just calls this main function, which is this big thing right here. And what we do is we call this await ethers.getSigners, which gets your signer from your Hardhat config, right? So wherever you see accounts like this, Ether says, okay, get me those accounts, get me those signers so I can actually sign and send transactions. Great, and then we just do a console.log, we're deploying something, and here's how we actually deploy stuff with ethers. Now there's a few different ways, and actually when we get to the starter kit, you'll see something a little bit different. But what we do is we call this ethers.getContractFactory, my first contract, which looks in this artifact thing for this my first contract that we've created, right? So when we create this my first contract factory, so this is my first contract factory would be like a little bit more precise. My first contract factory, you don't have to change it if you don't want. And then we'll do deployed contract equals await my first contract factory dot deploy. And now this deployed contract is an ethers.js contract that we can like start doing regular JavaScript stuff with. And so, for example, once we have it in our code, we can call deployed contract.setNumber. This is going to be the same as pressing that button in Remix to like send a transaction, right? But the good thing here is that instead of pressing buttons over and over again, you call a script and boom, you can press a million buttons at once. That's a lot easier. I don't like pressing buttons one at a time. I'm an engineer. I do things by scale. Then we can also do this bit of code here too, where we read from the contract. We call this getNumber function, and then we console.log it out. So what we can do is we can actually go ahead and run. Actually, what is we can run this script. Oops. Yarn hardhat run scripts deploy.js. And what this is going to do is it's actually not going to deploy it to Kovan. And you might be thinking, well, Patrick, why not? We just did all this work to get the RPC URL. We put our private key in here. What it's going to do is it's going to actually, it is going to deploy to Kovan. Excuse me. I take it back. It's going to deploy to whatever your default network is in your hardhat.config. I thought it was still Hardhat, but it looks like it's Kovan. So it's going to default deploy to Kovan. So when I run this, what do we think is going to happen? What's that? It's going to deploy the contract to Kovan. Exactly. So let's do it. So deploying contracts with this account balance, deployed my first contract to here. And if we waited a little bit for Etherscan to pick it up, we would see this contract on the Kovan Etherscan. So while it's deploying right now, then we awaited deployed contract.setNumber7. And then we waited deploy contract.getNumber, which still returned 0, probably because we didn't wait long enough to see it. Let me do let transaction response equals await transaction response dot wait 1. So sometimes if you do things, as Zach was saying, we have to wait for block times. So you'd assume this should say 7, right? Because we called this store, where is it? Set number 7. We probably just didn't wait long enough for the block to finalize, and that's why it still says 0. So I just added this transaction response.wait one, which says, hey, wait a block, like relax. And let's run it again. Let's see if it works this time. And this is really cool because, again, you now have the ability to have your deployments as customizable as you want. And if you're familiar with JavaScript, you'll be good to go there. Do I like Python? Yes, I like Python very much. However, at the end of the day, whatever tool that you like, is the tool for the job. I'm a big believer in whatever you want to do. So now we get the right response. Stored value in the contract is 7. So we'll have to go back. We'll update the exercise to make it look like this. And yeah, we can see it underneath this again. So that's kind of the real basic. This is like the minimalist level of Hardhat. And we're going to take, I think most of you guys, or who here is like done, hey, I got this part. This is super easy. Like, let's move on. Okay, 1, 2. Who here is like, man, Patrick, this is weird. I'm super lost. Okay, who didn't raise their hand? All right, nice. All right. The people who didn't raise their hand, where are you right now? I'm going to call you out. Mayor, where are you at right now? Oh, you're following along. Okay, cool. So people who didn't raise their hand, they're following along. Okay, cool. So we'll take 5 minutes then, or 10 minutes. We'll take 10 minutes and tinker around with this. For those of you who are like, I got this. This is super easy. Move on to the bonus exercise and try some of the bonus stuff. So I'm going to come walk around and we'll talk to people. Yes. Longest 5 minutes of all time, huh? How we doing? If you're feeling good, give me 2 thumbs up. Who's feeling good? Oh, we have a couple people feeling good. If you're feeling meh, give me 2 thumbs sideways. Meh, we got a number of meh. Okay, that's good. For those of you who are feeling meh, you were doing well. That's excellent. Why? Because you struggling through problems, struggling through these projects will make you learn more, and that's how you kind of keep getting better. So who's feeling terrible? That's not good. And if you're feeling terrible, well, it's fine if you're feeling terrible. It's okay. Who's feeling terrible? Well, we just unblocked you though, right? So you're feeling less terrible now. Yeah, you're getting through them though, which is excellent. All right, cool. Couple mez, which is great. 1 terrible, which is okay, and a bunch of double thumbs up. Great. And a peace sign. All right, great. All right. So no matter where you are right now, I want everyone to do me a favor and just kind of stand up and stretch. A ton of you have been sitting all this whole time, which is great. But get the blood flowing just a little bit. Do a little stretch. Get in the zone. Yeah. Andy's doing some calisthenics over here. There we go. Maybe say hello to your neighbor. Be like, all of you people who have made it this far have done excellent. You are all doing fantastic being here. You are all learning and becoming amazing smart contract developers. So, and everyone give yourself a round of applause for making it this far. Honestly, little round of applause for yourselves. You're doing great. Getting to this point here means that you have all of the really basic fundamentals you need to become a smart contract developer. And that's really exciting. You've deployed a smart contract. Some of you have probably never worked with Yarn or Node or barely even know what JavaScript is, and you've deployed a contract through that. Or maybe you haven't, and you've just got the development environment set up. No matter where you are, you have taken steps to learning this stuff, becoming a better developer, and you should be incredibly proud of yourself, and you should be incredibly proud that you've made it this far. So thank you all so much for getting to this point, and I'm really excited for your future. You are all the gritty, resilient ones here. So that's excellent. Excellent. Yeah, the powerlifting meet starts directly at 5, okay? Just kidding. So you've all done great. So I know some of you are still working on this JavaScript part, which is fine. We're going to go ahead and move on, though, to the next part, and feel free to keep working on the Hardhat stuff if you haven't gotten it yet. But yeah, we're going to go ahead and move on. And yeah, if you haven't gotten this part yet, don't worry. This next part we'll introduce new concepts that you can kind of just start from here if you want to. So let's get into it. Okay. Bonus exercise is cool. Okay. Now we're going to be doing 2 things. Who here loves waiting for your transaction to complete on Etherscan or on a testnet? Who here loves that? Who here, you love that? Okay, all right, I'm with that. All right. For a second, I was like, I don't know. All right, so he loves seeing it really happen, which is great, which is why we take you through that Etherscan stuff. But who loves sitting there staring at Remix or staring at your Hardhat going, did it actually go through yet? Or is it done? Who loves doing that? All right, who doesn't love doing that? Okay, great. We have a bunch of normal people here. That's awesome. Yeah, so that's kind of really annoying. And especially for developers, waiting for these transactions can absolutely destroy your development time. If all you're doing all day is waiting for this testnet to send you transactions, you're probably not going to get a whole lot done. So we need a better way to work with our transactions and work with our code. In Remix, we tested around with this thing called the JavaScript virtual machine, and Hardhat has something similar called the Hardhat runtime environment. This is going to be a fake blockchain, a local blockchain that we deploy on our little terminal that we can interact with, we can control, so we can do pretty much anything that we need it to do. And this will give us incredible power and flexibility in deploying our smart contracts. So that's what we're going to learn how to do now. And the way we're going to do this is with this thing called the Hardhat Starter Kit. Now, this is a Git repo, and I'll even I'll show you it here. That has like all the bells and whistles of what you need for a good smart contract project, right? It's a Hardhat project, and it's got a ton of stuff in here. Don't let that overwhelm you. We're going to be working with this. It's got a ton of stuff in here, but it's really going to show you how to do one of these local development networks and like what a good project looks like, or what we think a good project looks like. And the way that we're going to do this is first we're going to create a new folder because this is going to be a new project. So if you're in a folder right now, the way that I'm going to do it is I'm going to cd down a directory. I'm going to make a new directory. We'll call it, actually, we don't even need to do that. I fibbed to you. What we're going to do is we're going to do something called git clone. And if you, so there's some setup instructions for installing Git. You'll know you have it if you can do git -- version, and you see something like this. Git is a quintessential technology for all developers, which is why we put it into this, because you're going to use it at some point or another. And what we can do is we can do git clone and then paste that URL of this GitHub repository right into our terminal. And we're actually going to download all that stuff into our local development environment, into our place. Now I can do cd Hardhat Starter Kit. And if I do like an ls or a dir, if you're in Windows, dir, you can see all these folders, all this stuff here. And we're actually going to go ahead and open this folder. So we can do file, open folder, or code space period. And I'm going to open up this Hardhat Starter Kit. Yes. And now we see all these crazy files on the left-hand side, which includes all this stuff we need for a professional smart contract development environment. It's got stuff for local development, for deploying to real development. It's got amazing tests. It's got all this good stuff. So let's play with it. Let's play around with it. Let me just flip back and forth to my notes here. Oh, so now that we've installed this, what we're going to want to do is we're going to want to download the dependencies or the packages. There's a whole bunch of tools that this kit comes with that make our lives a lot easier, and we need to just install them. So you can do that with Yarn, or if you're using npm, you can do npm space install, and that's going to install all this JavaScript stuff, right? If you're familiar with JavaScript, again, it's going to go into this node modules thing, and that's where all of our dependencies are going to be. So we're going to download, first we're going to git clone the repo, then download the dependencies. And then as it's downloading, in the workshop, it says to do this mainnet RPC URL. I'm going to skip it for now, but we're going to come back to it, so don't worry. Now, while this is downloading all its stuff, we can go to that hardhat config.js again, which is going to be in the left-hand side over here. And this is going to look real familiar to what we saw before. If we look in here, we see the default network is this thing called Hardhat. So the default network for one of this fake local blockchains is called Hardhat. And when we run our scripts without like a network flag, without specifying otherwise, it's going to run this local blockchain that we're talking about, which isn't going to have, 7 minutes for us to wait for a transaction to finish, or, yada, yada, yada. And I'm still waiting for stuff to download, so that's fun. But once all this stuff downloads, we're going to do two things. We're going to spin up our own local fake blockchain with an RPC URL as well that we can connect to. And then we're also going to deploy a whole bunch of contracts all in one command, which is really exciting. And if we look into this deploy folder that we have, we've got 5 scripts, indexed from 0, which deploy a ton of contracts. Now, if you were in Remix and you wanted to deploy like 18 contracts, that would be 18 button clicks, which would be an awful lot of time and would probably not be very much fun. You're starting to see all the time saving that having a setup like this does, other than downloading the dependencies. So what we're going to do is we're going to run yarn hardhat node, or if you're using npx hardhat node, yarn hardhat node. And what this command does is two things. We have a package installed called hardhat deploy, which looks into this deploy folder and runs all the scripts that are in this deploy folder. And you can see kind of my terminal freaking out because it's running all these scripts. And it's deploying a whole bunch of stuff. It's deploying something called mocks, which I'll talk about in a bit. It's deploying this price feeds. Let me scroll down. It's deploying this price consumer v3 contract, which I'm going to open that up. Price consumer v3.sol, which is exactly the price consumer stuff that we worked on earlier. We deployed an API consumer with this script here, which does the exact same thing. Random number consumer, which this one's actually the version 1 of VRF. I haven't updated it for VRF 2 because it came out yesterday. Sorry. And then number 4, which is keepers, which is something that Sol demoed earlier this week. And so we deploy all of these with that one command. Yarn hardhat node deployed all of those contracts onto our fake little blockchain, and then it did something else really cool. If you look in your terminal, you can see all these accounts and stuff and all these private keys. These are fake private keys. These are fake accounts that they just give to us that start with 10,000 ETH each that we can use for playing around and doing stuff. We're also given one of these little WebSocket things here. What does this look familiar to? Looks really familiar to that Coven RPC URL thing, right? What do you think would happen if I stick this into my MetaMask? Bingo, spot on. So let's try it out, right? So let's go to my MetaMask, or not. Let's go to my MetaMask. We'll go to this little button here. We're gonna hit Add Network, and I know this isn't in the workshop, but it's fun anyways, and it's it's good info. We're gonna hit Add Network, and now we can add a new network. I'm gonna call this Hardhat localhost, and we're gonna add. Oh, I already have it. Looks like I already have a Hardhat. I already have a Hardhat local network. Sorry, but you can all add this in here. The chain ID is going to be 31337. Currency symbol is going to be ETH. There's going to be no block explorer, obviously, because this is our own like local one. And you would just hit create. I'm going to close it out now, and then you'll get one of these networks, Hardhat local. Now, obviously, we have nothing. We have no money in here, and I want money in here. So we're going to copy this private key, or any private key you want. We can hit the little icon here, import account, paste your private key, import, and boom, now I'm a gazillionaire. Yay. And this is how you can work with your own local blockchain with MetaMask, with front ends, with all that stuff later on. We're not going to talk about that now, but that's basically how you would do it. Hardhat, yeah. So you can change in your config the network ID, but it always defaults to 31337. Great question. Always defaults to 31337. Yes. So now that we have all that up, we can actually start interacting with these contracts. Why can we interact with them? Well, because we have this tasks folder, which has a whole bunch of tasks that we can do. These are like scripts that have already been pre-written to interact with our contracts. For example, if I wanted to read the price feed of one of these fake contracts deployed to our local chain, we can call this read price feed. And I know I have like a million things up there. We can call this read price feed task that we've already coded in JavaScript. And what this does, if you go through and read it, it just calls that get latest price function that we saw in Remix. That blue button, it's exactly what we're doing in code. So we'll keep this. This terminal up because we want to keep our node running, right? So that we can actually interact with it. Now, what we can do, and then actually it even prints out the commands for us, which is really nice. If I want to call like one of these price consumers, I can just I copy this right here into a new terminal, paste it. And so this is going to do yarn hardhat, read price feed, which is the task name in that task folder. We pass a flag of the contract address, which it gives to us, which again, we can double check. We can read right in here. It says, okay, deploying price feed consumer, deployed to here. Excuse me, deployed to here. -- network localhost. So localhost is the name of like this hardhat fake blockchain that's running right now. Now, if I hit enter, what do you think is going to happen? It's going to show a price here. Now you might be thinking, hey, Patrick, that's like a really super round number. How is that possible? Well, what is it reading from? It's reading from the contract that we deployed. However, when you guys all worked in Remix, you saw there was like some crazy address, right? That address is like a real address on a Coven network, on a Rinkeby network, etc. We did something called deploying a mock. So when we spin up our local network, are there going to be any price feeds on that local network? No. Why not? There's no oracles watching that. Exactly. There's no oracles. There's no infrastructure watching my computer waiting for me to spin up a hardhat network. I'd have to be a gazillionaire for that. So what we do is we deploy our own fake price feed, and these are known as mocks. And you can see that in this deploy mock script. If we scroll down in here, we have this function, this section here saying await mock v3 aggregator, which is a fake price feed for us to call from. And we can even look. We have it in our contract/test. We actually just imported it from a package to use it. But it goes ahead and deploys this price feed for us. And that's why you see it that round 2000 number, because we've defaulted it to always be 2000. Pretty cool, right? I think it's pretty cool. Now, the follow-up question to this might be, okay, Patrick, that's cool. We deployed this fake one, but I want to interact with like, or symbolically work with, what if it was like mainnet? I want to pretend to hit a mainnet one. How do I do that? And this is where that mainnet RPC URL thing comes in. So if you have Alchemy or Infura or wherever you went, you can create a new project with a mainnet RPC URL, and then create, and then in your .env file, well, you know, or I have all mine already set up, but you can add a mainnet RPC URL environment variable, and you can do this thing called forking. You would just uncomment this, and excuse me, and put a comma in here. And then you could deploy your contracts on a local blockchain that's pretending to be mainnet. So it has all the contracts of mainnet in it, and it allows us to kind of like pretend we're working with mainnet, which is really cool. Now, again, working with oracles can be a little bit tricky because there's no oracles watching this pretend mainnet, and mocking can still be really helpful, but this is another way to kind of test and work with your smart contracts if you'd like to. I'm not going to go through it right now, but if you want to go through it in the exercises, you know, you're more than welcome to. And yeah, and in the instructions it talks, there's only one other thing that we need to update. We do just need to comment this part out in one of the scripts. It talks about it and add this piece, but I'm not going to demo it. I'll let you guys demo it if you so choose. And yeah, and then you can test it, and then you can read from it. Okay, cool. Now, before I let you all go off and play with all this stuff, oh, wow. Now, before I let you go off and play with all this stuff, I need to ask a question here. So if I run, let's look at this API thing. If I run this command here, we have a command real similar to Remix called request data. Remember that blue button in Remix to request data? We had to fund it with link and stuff. If I call this function, do you think I'll get a response on the local Hardhat network? What do you think? I heard a yeah. Okay. Why? Sorry, what was that? So he says yes, because we can build a small server on the computer. Yes, but we didn't do that. So we won't get a response because there's no Chainlink node watching our local blockchain. If we were to spin up a Chainlink node here, we would get a response. But if we do this right now, it's just going to be like, yeah, cool. And it might even fail. Well, it failed because it doesn't have any link. But yeah, so we're going to take another 10, 15 minutes. We're going to let you play around with this. I know there's a lot of information here. Actually, before we give you that time, does anyone want me to walk through what all these folders and files are for? If you do, thumbs up. If you don't, thumbs down. Okay, mostly thumbs up. Okay, I'm going to walk through everything that goes on here. And the cool thing about this is that this is a super sick setup. Gives you, like, if this is where you start your project from, you're starting on good footing because there's so many tools here for like a professional environment. So let me walk through this. Artifacts. Whenever you run yarn compile, this is where all like the compiled bytecode goes, right? So we can pretty much ignore this for the most part. Cache is like a cache. You can pretty much ignore this as well. Summary, ignore these two. Contracts. This is where all your contracts are going to be. So API consumer, keepers, price feed, random consumer, all your Solidity code is going to go in this folder. So when you're like, hey, I want to make a new contract, stick it in here. Now you'll see this test file in here too. This test file is where we put our mock contracts. So remember I was saying, oh, we have a fake price feed. This is where we stick it. Any of your fake stuff that isn't really associated with your project, you put in this contract/test folder. And just ignore the little red linting there. So all Solidity stuff goes into contracts, and then our fake mock stuff, contract/test. Deploy folder. So in the last demo, we wrote our own like little deploy scripts. In here, we have a deploy folder, which whenever we hit yarn Hardhat node or yarn Hardhat deploy, it will run through every script in here for us and just do everything. So it'll do the deploy mocks, deploy price feeds, deploy API consumer, etc. And I can go around and kind of talk to you a little bit more about deploying one of these. And for those of you who are like, Patrick, I got this. This is super easy. I'm going to highly recommend that you create a new contract and then create a new deploy script and try to deploy it to both your own local network, first, and then a test network. Why your local network first? Why should you deploy to your local network first? What's that? It's faster. Exactly. It is much faster. Our lives are going to be substantially better if we can iterate over our, have you ever like ran into a bug in your code and between like checking out if it's right, you had to wait 5 minutes? That's awful. So we want to do local first always. Great. Deployments. This is where whenever you deploy something, it actually saves where you deployed something. So if you're deploying to Rinkeby or Coven or mainnet, and you go, oh my God, I deleted my terminal. I don't know what the address was. It'll all be in this deployments folder, which is really nice. Node modules. This is all the JavaScript package stuff for all of our stuff. Scripts and tasks basically are the same thing. To run a script, like what we did before, you do yarn Hardhat run, script / the name of the script. Tasks is a little bit different. You can just do yarn Hardhat and then the name of the task. I personally like scripts a little bit better, but there are some things that tasks are better for, so it's really up to you. And scripts and tasks, they might be like, oh, if you need to do something over and over again, or you just want to automate some process, you'd put it in scripts or tasks. Testing, we'll get to this. This is where you do all your tests. Tests are absolutely critical when it comes to smart contracts, especially because if you don't have tests, then you could make a change and it could blow everything up, and security is essential in this space. So we have some tests in here. We have two types of tests, unit and staging. Unit tests are kind of like really small, testing a single piece of your contract. Staging is testing like a testnet, or we used to call it integration test, but staging is a little bit more accurate. That's when you deploy to Coven or Rinkeby. Staging tests, working with a testnet, should be the last thing you do before you deploy to like a mainnet or a real thing, because you want to do everything locally because you will be so much faster. Great. .env.example. This is just an example .env file. Get attributes, you can ignore for now. .getignore. This is the file that when we deploy stuff to GitHub or we send stuff to GitHub, it says, this is the file that says, don't push this stuff to GitHub. And we absolutely want to make sure we always have this .env file in here. Because when we push our private key to GitHub, you will get your funds stolen, guaranteed, 100%. Somebody will find it and will steal your funds, which is why whenever I'm developing, I always use a burner MetaMask. I use a MetaMask that doesn't have any money with it, and then I'm cool to share on stream because I don't trust myself. I think I'll screw things up. And so just never, ever develop with a private key that has real money in it or a MetaMask. So just in case you do accidentally push it up, but this will help prevent you doing that. .npm ignore, we can ignore that. Prettier ignore, this is a file that ignores, that tells our formatter to ignore these things. So if I go to our price consumer v3, and I want to make this like ugly, look at this. Oh my goodness, it's so ugly now. Whoops, it auto formats. Look at how ugly this is. It's got so many spaces and save without formatting. It's so ugly. We have this other file in here called Prettier RC. And what it does is it'll actually format all of our files for us. So I think it's called yarn format. And boom, it made it pretty for us. It made it auto formatted. So Prettier ignore says, hey, formatter, don't do that to these files. Solhint, this is another formatter, but specifically for Solidity. It's technically what's called a linter. So not only does it format things nicely, but it also might warn you about best practices. So it does both. So you can check that out by running yarn lint. And it runs this Solhint thing, and it says, hey, here's some things you might want to think about that might not be the best practice, which is really nice. Solhint says, don't run the linter on these files. Hardhat config is the Hardhat config. Helper functions are like some nice functions. So we have this auto fund function, which automatically funds contracts with link. We also have this auto verify function. So if you have an Etherscan API key, you'll automatically verify your smart contracts on Etherscan, which is really nice. And if you want to learn how to do that, let me know. Hardhat helper config, this is just where we store different addresses on different chains for different configuration purposes. This is license is like an open source, hey, who can use this code? Package.json, this is like defining what dependencies it needs. And then yarn.lock is saying these are the exact dependencies it uses. I know that was a lot. Any questions with any of that? And then we'll give you some time to play around with this stuff. Any thoughts, comments, questions? Yes. Yes, so the question was, can you elaborate on tasks versus scripts? Tests. So he said, can you elaborate on tasks versus tests? Is that right? Okay. Yes, great question. So when I want to just run some random script or do some random thing, that's what I use tasks for. But when I want to test my entire smart contract end to end, that's what I want to use tests for. So I can run yarn test right now. And what this is going to do, it's going to go through all of my contracts and all of my test files and test them. So I've written some things to say, hey, if we call get latest price and we get a string, that's wrong. We should get a number, right? Stuff like that. Versus a task might be something like, read price consumer. So, and imagine this. Imagine you had 100 contracts, right? And each contract had like a read price number. Would you want to go through manually, call 100 tasks to make sure it works? No, you wouldn't want to do that. So you would do all of that in your tests. Tests are way you run yarn tests or yarn hardhat test, goes through all of that for you and just automatically tests everything. So that's good question. Any other questions? All right, cool. So we'll give everyone 5. Or Actually, before we give people 5-15 minutes, who is like, yes, I'm ready to play around with this, and I'm excited to play around with this? Okay, got some thumbs up. Who is like, I'm kind of confused, I don't really know what's going on? Sideways thumbs. Okay, we got a couple. I'll come around. Who is like, who didn't put a thumbs up? Thank you for your honesty. All right, cool. We'll give 5-10 minutes, play around with this stuff, and we'll be around for questions. All right, so a couple people have moved on. Who here feels pretty confident, feels pretty good with the local host stuff? Got a couple thumbs up, couple maybes. Who here's not feeling so hot about the localhost stuff? Who's like, I'm kind of confused still? I said I would come to you. I have not yet. I will come to you as well. We'll give it another 5-10 minutes.
All right. I see people tinkering. I see a lot of really cool stuff going on. I'm giving you all a ton of time for this stuff. So we just did localhost, which is great. But a lot of you want to know, how do I actually deploy stuff to a real testnet? And the way that you're going to do that is nearly the exact same way that we did it before with the deploy script. So I'm going to kind of speed through this, though, because we've done most of it already, right? So back in our .env file, or I'm just going to do it with my example. I'm not on the screen? Okay, I'm not on the screen. Can we flip me back on? Woo!
Should she?
I'm not sharing screen. Did I unshare screen?
Aha!
Sorry. One second. Screen share. Share screen.
Better?
All right, cool. Voice.
Woo! All right.
So my .env.example, this is where we had like the main .rpcrl, alpha.rpcrl, and remember in our deploy script from before, we had our private key, we added these different RPCRLs.
So all we need to do, if we want to deploy to Polygon, Ethereum Mainnet, Avalanche, Binance Smart Chain, Covin, Ringpy, whatever, you just add a new one of these URLs in here, and then your Hardhat config, you just add a new network, kind of similar to like what we see here, right? So like you'd add the name of the network, the URL, your private key, and then the chain ID, and then any other configurations that you want, right? And once you have all that in here, you can either change the default network at the top, like we did before, to Covin or et cetera, or you just do yarn hardhat deploy. You just pass the network flag, dash network, and then whatever the name of the network is. So like Covin, for example, or Ringpy or whatever. Now the thing with this is you'll need to have, the network set up in here. You'll need to have in your helper Hardhat config. You'll need to have, all these variables set up correctly, depending on your constructor parameters. So that's pretty much it. And I'm probably going to cancel this because we're going to have to wait for like 6 transactions, and I don't really feel like waiting. But if you want to do that, feel free. Hence, again, why I say, this should be the last thing that you do, deploy to a testnet, deploy to an action network, because you're going to have to wait this long period. So I'm just going to cancel because I don't feel like waiting. But that's pretty much it. Now, I'm also not going to, I'm not going to spend too much time on it, because if you want to work with it, if you want to do it, you're more than free to. You can take the time to, and it's all on that worksheet that we see right here. And then interacting with them, it's going to be the exact same way with working with localhost. So you just run these tasks, you write a script, etc., and it'll, instead of just calling your localhost, it'll call the actual network, which is really exciting. So, price feeds, APIs, random numbers, bonus exercise. So for the bonus exercise here, and I actually am going to do the next part too, and I know I'm kind of speeding a little bit, but I want to cover a couple more things. For the bonus exercise, if anybody feels up to it, create your own task. So look at kind of the tasks that are in JavaScript, create your own task, see if you can do that. That'd be really fantastic. Bonus exercise 2, and this is like super bonus exercise, is figure out how to do this with the Chainlink keepers. The reason that this is the super bonus exercise is because we've shown you nothing to do with keepers here. Sol gave a fantastic presentation on keepers, on Chainlink keepers 2 days ago, a day ago, 2 days ago. Definitely go check out that video later on, and then apply those learnings to Hardhat. There is some boilerplate code in here already for working with keepers. Keepers counter right here. This is like a real minimalistic contract. You just need to go to the Keepers UI, follow along with Sol's tutorial to learn how to do that. But what I want to get to is testing smart contracts. And I mentioned as well, or we mentioned we would do a little bit of security here. That might be a little too advanced for where we are, but maybe we'll do it for fun anyway. So testing our smart contracts. Like I was showing you all before, when we work with our code, when we want to see if our stuff actually works, one way to do it is to write a ton of tasks and a ton of scripts and run them one after another and manually make sure they all work, which is obviously awful because that is a huge waste of time. So what we do instead is we create this little test folder, and we add something called our tests in here. So let's look at the price feed test because it's one of the simpler ones. And then I'm also going to stop my localhost from running. And we're going to close it here. What this does is it goes through all of our contracts, and we tell it, hey, here's what we expect to happen when someone interacts with this contract. And this is absolutely quintessential to writing smart contracts because, as you know, if you screw up a smart contract, it can be disastrous for your users, right? So we want to make sure we write really, 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 really good tests. And here's kind of this price consumer is a minimalistic example. What you end up doing in here is we deploy our contracts in this before each. This before each loop basically says, hey, before every describe, before every it block, we're going to do this. So we're going to deploy our mock contracts, and we're also going to price consumer V3. Yeah, we're also going to have our price consumers deployed. Excuse me, with this feed tag, and then we're going to run some tests on it. So the first test we're doing in here is we're just saying, hey, it sets the aggregator address correctly. So we do this thing called const response equals await price consumer v3.get price feed, which is just calling that get price feed function, and we make sure that that response is the address that we gave it, right? And then our next test in here, this get latest price, make sure that the latest price that we get from our local contract is what we expect it to be. And I know I'm kind of going quickly through this too, but we can run this with yarn hardhat test or just yarn test. So if we do yarn hardhat test, we're going to get a whole bunch of stuff get spit out. And if you see check marks, that means tests are passing. And if you see little red X's, that means tests are failing. So obviously we want everything to pass. And great, we have 11 passing. Now, something else that's really cool is that a plugin with this is going to be a gas estimator. So everyone here knows that whenever you make a transaction, you have to spend some gas, which users typically don't want to do. People don't really want to spend money. So we want to always figure out, okay, how much gas are we spending on these? So we have this plugin here called Gas Reporter. And when we run our tests, with this enabled, it'll actually give us an output saying, here's approximately how much gas each one of these functions costs. So to enable that, back in our .envs.examples, we would just add this report gas equals true. So I'm even going to do that right now. I'm going to create a .env file. Most of you have yours already. .env. Report gas equals true. And now when I run my tests, we're going to get a wonderful little output saying, here's approximately how expensive it is to do everything, which is really nice. And the reason it knows how much stuff costs is in our tests are simulating running all these functions, and then it goes, oh, okay, cool. When you ran that function in our test, this is how much gas it used. And so the way we have it set up in our Hardhat config, we gave it this output file, gasreport.txt. And what we can do now is in our files, we can find it right here, gasreport.txt, and it's super zoomed in, so it's kind of awful to look at right now. I am going to zoom out a little bit, and so, well, now it's even more awful to look at. But it has this, has like the average gas each one of these functions cost to make, which is really exciting. And then additionally, you can figure out how much it costs, like in US dollars or any other currency. And the way to do that is you change the currency to like USD, and then all you'd have to do is add a CoinMarketCap API key. So you can go to CoinMarketCap, get an API key, stick that as an environment variable, and then it'll tell you in USD as well. But if you kind of don't really care, or if you can kind of do the math between the gas and how much it costs, then great. But we can see in here, for example, how much the deployments of each one of these costs, right? So deploying the API consumer is more expensive than deploying our keeper's counter contract, right? Deploying API consumer is more expensive than price. Price consumer is one of the cheaper ones. We can see kind of the contracts and the methods. And sorry if this is too small. Like we see how much request volume data costs and all kind of the different costs, which is really, really nice. Yeah, and then additionally, I probably should have mentioned this before. Yes, one sec. Move the other mic. Oh, like online? Yes. All right, so I'm getting some feedback that there's a little bit of echo. It's probably because I'm talking and then the mic is also talking. That's kind of annoying. What's up? Okay. I got to mute my computer mic. Yes. I'm going to stop sharing for a quick second. Oh, I can do that at StreamYard.
Oh, okay, I'm muted. Oh, perfect. All right, I'm going to share screen again. Yay, we did it. Good job, team. Am I back up? Oh, can we have me back? Sorry. I had to unshare and then reshare. Apologies. Yay. Cool. Now, the other thing that we can do is when we deploy one of these contracts, this GitHub repo comes with this this verify task, or this helper function, which I briefly talked about. But it comes with this verify function. If we deploy to a testnet like Rinkeby or something like that, and we have an Etherscan API key set, you can find it pretty easily. Just go to Etherscan and get an API key for free. You'll auto-verify your smart contracts on something like Etherscan so that other people can read them, which is really nice too. And similarly to like us deploying to like an actual testnet, we can also run tests against a testnet, which takes a really, really long time, which is why this should be the absolute last thing that you do. And you do yarn test -- network, and then Rinkeby, Coven, whatever you want. And it'll run your test suite on an actual testnet. Now, the way we have these tests set up, though, is you don't want to run every single test on a testnet. For example, I don't need to run priceconsumer.getPriceFeed on a testnet. Why? Because it's not really interacting with many other contracts. We want to run against a testnet. We want to run against like other real contracts, other oracles, other stuff like that. So you'll see staging is just a totally different set of tests here, and we have this thing at the top that's saying, hey, if it's not a testnet, we're going to skip it. Describe.skip means don't run this if you're not on a testnet, which is good, which is what we want. We only want to run the staging tests on testnets, and we only want to run the unit tests on our local networks. Cool. And then, yeah, you'd deploy your contracts, and then you'd run yarn test staging. All right. In addition to writing really good tests, there's this concept in writing tests called coverage. If I look at one of my contracts here, excuse me, price. If I look at one of my contracts here, and I write a test for get price feed, but not for get latest price, are my tests good? Have I covered all the use cases in my smart contract? No, that's not very good coverage. So we have ways to run automated scripts that say, hey, here's approximately how much coverage you have, so that we can know, we need to write more tests. We need to be more thorough with this. So to run that coverage, you can do yarn hardhat coverage, add this little -- test files, and tell it what test files to use. And what will happen, oops. Is it'll run our tests again, but this time it'll check for coverage. So similarly to the gas one, which spits out how much gas based off your tests, coverage spits off how complete your tests are, right? And so we get this little file at the end saying, hey, here's the percentage of lines that we've approximately read that have good coverage. We can see, well, we can see our mock oracle.sol hasn't got great tests, but we kind of don't care because it's a mock, it's a fake one. We can see that our API consumer.sol only has 92% test coverage. So this might be an indicator to us, we're missing some functions, we're missing some test coverage. And it could be that 2% that we didn't write tests for that get exploited. So that's why this is such a useful feature, because it'll give you real quickly a snapshot into what you need to have tested. And that's it for that. We are going to give you time again, because we're reaching we have about 40 minutes left. So we are going to give you time to play around with that as well. But I do want everyone here to be successful in writing and pushing to their first GitHub repository if they've never before, okay? So if you've never worked with Git, this is going to be a phenomenal experience. If you have worked with Git, this is going to be a refresher for you. So what we want to do is, well, you can actually, well, you can skip this first part, but just make sure that your repo looks pretty good. And what you're going to want to do is you're going to head over to GitHub. Yes, I would like to head over to GitHub. And I'm not going to sign in. I'm just going to go through the workshop here, but feel free to grab me as we go along. And we're going to create, we're going to go to settings and go and create your own personal access token. This personal access token is going to be like basically your password to signing into GitHub via the command line. Once you have that, you're going to create a new repository. Now, the reason why this is, and I actually should have explained this before, the reason why GitHub is such a crucial, well, or Git in general, such a crucial thing for developers is people mess up. Who here has always written flawless code? Yeah, okay, yeah. She was like, yeah, no, yeah, nobody's written flawless code, right? That's insane, and it's good that we don't write flawless code, but we need a system to kind of keep track. And if we test something that doesn't work, we could easily revert back, right? We can go, oh my gosh, I made all these changes that didn't work. Let's just go back to where we were like 2 weeks ago, right? Almost like a history of our code. And this is called version control. Like, what version of our code are we on? What version are we working with? And it's essential for smart contract developers, especially. And GitHub is a system that allows us to keep track of all of our changes. So if 1 week you say, hey, you know what? I'm going to delete everything, start from scratch. And then 2 weeks later, you say that was a terrible idea. You can easily revert back to where you were before. So once you create one of these new code repositories, we're going to push all of our code into this website, which will hold our code and will hold this versioning for us. And there's some commands here to do it. You can kind of copy, paste, and follow along. Git init creates like a new, actually, well, so since if you did the, if you're working on the starter kit, you already have like a Git initialized. So if I did Git init, it would get mad at me. But if you make any changes, you can like see all your changes by writing git status, right? So I made some changes to hardhat.config.js, and I can see it says, hey, you've modified your hardhat.config.js. I can do a git diff. Let me even zoom in a little bit so people can see a little better. I can run a git diff, and I can see exactly what the changes I made were, right? Right now, it doesn't look like there was a whole lot, but maybe I say, hey, you know what, price consumer v3.sol, I don't really like this function, or I want to make a new function called function do stuff. And it's going to be a public view that returns a uint 256 or whatever you want it to do. And then we're just going to say return 7. Doesn't do a whole lot of stuff, but that's what we're going to say it does. Now if I do a git diff, it's going to say, hey, you've created all these changes. This is all this new stuff that I've never seen before. And we go, great, we want all that new stuff. So what we can do is we can do a git add, period, which will say, hey, take all that new stuff that we did and add it to like a staging place. Like we're highly considering adding this to our permanent history. Now if I do git status, you'll see it's all green. It's saying, hey, these are the files that you have in staging. We're ready to commit them. We're ready to permanently make them in your history. I'm going to do it on a different branch. And you can do this. You can do this or not. It's up to you. I'm going to do git checkout -b new branch. And a branch is basically, if you think of like your code history, where main is kind of this really straight line, me making new branches saying, I'm going to do some stuff over here. So now anything that I make on this other branch will always stay over here, and our main branch will stay unscathed. So I'm going to make this new branch, and I'm going to say, I'm going to permanently add those changes to this new branch. I'll do git commit, and I'll give it a little message saying, you know, playing around with Git. And on my local host, what's happened on my local machine is I've created this new commit. If I go to what's called the git log, I can see the most recent commit, the most recent permanent code addition is me playing around with Git. And so now I have this permanent piece of history. And if we do Git status, and now it doesn't have anything in here. But if we do Git checkout main, you see that function disappears because we didn't commit that to the main branch. We committed to our new branch. But if we go Git checkout new branch, this returns because that commits on the new branch and not on the main branch. So once we have it committed, we want to create a new remote. So the remote is like where we're going to push all these changes. It's like, hey, we want to store all these changes on some website. And right now, if we do git remote -v, the origin is the Hardhat starter kit because that's where you cloned it from. So whenever you clone something, it automatically says, okay, we're going to store all your changes on the place you cloned it from. But we don't want to do that. We want to give you a brand new repository. So we do git remote remove origin. And now if I do git remote -v, I get nothing. I have no remote repo. There's no place for me to push my code to. There's no website that's going to hold my code. And we don't want that. We want a place to hold our code. So this is where we're going to add that new repository URL. So for example, if I had my repository called the Hardhat starter kit, or whatever your new repository URL is going to be, you'd copy it. You'd run git remote. I think it's add origin. Add origin. Paste that URL. Now I do git remote -v. I now have a remote repo named origin that says this URL. And now anytime I want to push my code to a website, it'll push it to this URL, which is really helpful. And that's what you're going to do. You're going to run this git push origin main. GitHub might say, hey, what's your username and password? You type in your username and you type in that personal access token. And then when you go to your repositories, you should see all your code on your profiles repository, and boom, that'll be your first GitHub repo. So for the next 15, 20 minutes, I would love to see everyone with a new GitHub repo, especially if they've never done it before. I'd rather see that than fiddling around with Hardhat, but you can also fiddle around with Hardhat. So let's see some repos.
Yeah, also, quick announcement. Since y'all have worked so hard and made it so far, and we're getting to the end here, we're going to be passing out passes for everyone to get Uber credits and go to our happy hour that we'll be hosting after this. So we'd love to have you there. Come mingle, drinks on us. It's going to be a great time. And we'll also be giving a feedback survey at the end of this where you can give an address to us, and after the bootcamp, we'll send you POAPs. Right, so you can prove to people that you were here and you made it to the end. So thanks for coming out, and yeah, I'm super excited to see those Git repos made.
What up, what up? So hopefully some GitHub repos are coming online, which is very exciting. We're getting pretty close to 5, which is also kind of exciting. You all have done fantastically. Probably in 5 or 10 minutes, we're going to do a quick photo of everybody who made it this far over here, which is really exciting. Congrats to you all. And I know I mentioned in the marketing of this that we would do a little bit of security. It looks like we might want to hold off on that. People are still tinkering and stuff. We don't have it on the screen, but in that workshop, in those exercises, there's a link to an article that we wrote with Certic, which goes over some of the most common attacks, the different attack vectors, and then how to protect against those. So might be something you want to check out. Feel free to ask us a ton of questions. Security is obviously incredibly important in this space, and it's kind of fun. I think it's really fun when you can say, hey, like this is an exploit that we've avoided or we learned how to avoid. It could be the difference between a very successful protocol and a not so successful protocol. So definitely something to check out. But we'll keep having people do GitHub repos and tinkering with Hardhat. And then in the next 5-10 minutes, we'll wrap up. We'll take a picture. We'll send some POAPs. We'll get some movers. And then we'll go to the happy hour where we can sit back and we can go, oh my goodness, I learned so much today. Learned about Hardhat, smart contracts, all this other crazy stuff, forking, mocks, verification, and just chill out and enjoy the company of a ton of really, really smart people. So Zach will probably actually wrap things up, but I wanted to say thank you all for coming here. Thank you all for staying. I'm so proud and impressed in all of you who have gotten this far because there's so many of you have done things that you've never done before and that are really advanced, and you did it in like less than 8 hours. So just once again, I know we already did it, but give yourself a little round of applause. Excellent job, everybody here. Really, really excited to see everybody kind of learn and grow. And just a little bit of a backstory. This is how I got into this space. 2 years ago, I came to EthDenver. I sat at a table just like the ones that you're sitting in, and I just practiced Solidity all day, running into probably the exact same things that you're all running into right now, going like, what is going on? And just kind of the time behind the wheel. And then 2 years later, maybe you'll end up teaching it. So you're in a great spot. You are doing fantastically. You are on the right journey. So thanks.
Hey everyone, just to add on to those closing remarks Patrick gave, that was an awesome speech. Really, congrats. Great job, everyone. It's been fantastic. You've asked some very good questions here. I can tell you've all learned a lot. I look forward to talking to you some more when we're done here. And right after I'm done here, we're going to move over there, and I'd like to take a group picture with everyone that was here. And we'll record this down in history, EthDenver 2022, Chainlink Bootcamp. Just to wrap up, if you're curious where you can find some more information after this bootcamp and continue your developer journey, the Docs is a great website, docs.chain.link. As you know, we've gone through it many times today. There's the blog where we cover the blog covers more specific topics, sometimes tutorials, security stuff, all kinds of interesting subjects, project ideas. And of course, the YouTube, right? So there we put developer tutorials on the YouTube all the time, cool panels, videos. This will be up on the YouTube if you want to rewatch it. Market.link we talked about in the API section. And our Discord. Our Discord is a great place to go and talk with other community members at any time. It's always very active. People can come out and help you, discuss subjects, point you in the right direction. All kinds of cool places. And I'd like to add, if you go to chain.link/bootcamp, this is going to be our bootcamp hub from now on. So we actually ran an online bootcamp before, and you can find this bootcamp right here that we just ran, and we'll post information and all these resources here when this is done. And you'll see future boot camps coming up and past ones that have been completed. So here's some of the old ones that we did. And other than that, this is the feedback form, and you can drop an address, and in the next couple of weeks, we'll send out a POAP to this wallet and get you all set to go. So yeah, please let us know how you felt about this. If you have any critical feedback, we always accept critical feedback. We want to make these even better in the future. So thanks again. This has been fantastic. I've had a blast. This is actually my first EthDenver, so it's been amazing. Yeah, so fill out the feedback form and let's go ahead and take a picture.
And quick announcement. Anybody who wants a bunch of food, there's a ton of leftover food. So if you go down the hallway, take a right,